Hello and welcome to the complete CompTIA Network Plus Mastery course. I am super happy that you are here because you're in for a treat. You're in for a journey. Now, in these next few domains, few sections and few lessons, I will transfer everything I know about computer networking into your brain. And by the end, hopefully you will take the CompTIA Network Plus and then be able to pass that exam. But why did I decide to do this class? Well, there's few reasons. One of the reason is over the few years ago, I've seen a lot of people coming into cybersecurity without prerequisites. I don't know where they're getting kind of these devices from. People are telling them just jump into cybersecurity. So I say, you know what? Let me go in and create that CompTIA Network Plus course so that I can help give people the prerequisites, the networking knowledge that is needed for them to thrive in the industry of cybersecurity. Or if they just want to become network engineers, that also works, but you got to know networking. So networking is crucial because this is how two computers talk to each other. And when you go in and try to secure things, well, if you don't know how two computers communicate, well, you're not going to make it. The other thing is, specifically, I'm talking about cybersecurity because that's what I specialize in, and you will learn about that in a minute here. But when you look at these people attacking us, these people attacking our infrastructure, well, they're using the network. They're not sitting next to you and then, physically hacking you and things like that. No, no. They're sitting in other countries and they're coming through the network into your environment. If they're stealing things, they're stealing those things through the network and then taking them to wherever they are. So it kind of makes sense for you to learn this network that everybody's connected to and everybody uses. So that's really what this course it's designed to do, is really to help you understand the world of computer networking. So I am glad you're here. Again, I don't take this slightly. There's a lot of resources that you could have utilized, but you are here. And for that, I am grateful. With that, let's get right into it. So who am I? Who is going to be teaching you this content? Well, my name is Francois Arthanas, and I've been doing cybersecurity and IT related things for the past 10 years plus. I started off working as a help desk, really tech support, IT tech support. I was upgrading computers. This was within a school system environment. So we were going into from elementary school, high school, middle school, kind of upgrading those school computers. We were, pushing to the latest version of Windows, upgrading tools, connecting them, connecting the wires, the cables, the RJ445 cables, running wires throughout the school buildings, that kind of stuff, which it was fun. It was really good. And from there, I became a system administrator, sysadmin. So I was working with Windows environment, so Active Directory, group policy, Linux systems. Then after that, I started teaching. Right, I went into teaching, but I didn't went all in because I felt like I still needed that practical experience, that hands-on experience. So I kept on teaching on the side as an adjunct professor. So I teach at different places like WGU. There, I was teaching there. And a few other kind of logos that I didn't, get a chance to put them here. But I worked as an information security officer for Trinity Health Team. From there, I worked for ISACA. I worked for Centene. Just like I said, been there, done that, done a lot of things over the years, and I'm hoping to transfer that knowledge, that practical knowledge, onto you as I teach you this. So one of my kind of a mentor over the years have told me that, hey, Francois, if you stop learning, the moment you stop learning, you start dying. I said, huh, that kind of makes sense to me. So over the years, I said, I'm now going to stop learning. And cybersecurity is the industry, because that's what I specialize in. Cyber is the industry that you cannot stop learning. As soon as you do, you become out of date. So over the years, I've taken a lot of certifications. They're listed here. Some of them are not even listed here, including the Network Plus, which is what I'm helping you kind of prepare for. But I've taken certifications from the A Plus, Net Plus, Security Plus, CISA Plus, Linux Plus, and Security X, which which is the CASP Plus. They recently branded it. The CISSP, the CISA, the CISM, you name it. Taking the CEH, all kinds of stuff. But when it comes to academic wise, I've a bachelor's degree in network management. As you can see, networking has always been there. Master's degree in cybersecurity from WJU, and currently I'm doing a PhD in cyber defense from Dakota State University. So as you can see, I love knowledge. One of my friend called me like a knowledge maniac because I just keep studying and studying and studying. So I'm hoping to transfer some of that knowledge to you and along the way help you pass this Network Plus exam. Now, you are not here to just listen to me talking about myself, right? You are here because you care about you, and maybe you're trying to change your life. Maybe you're trying to get into IT. Maybe you're trying to get into cybersecurity. So the question is, why are you here? I often ask this question live when I'm teaching this class live so that I can understand where students are coming from. I want to know why they are in my class, not because they choose my class. No, no, no. Like, what's the reason? What is their reason of being here? So most of them, when I ask this question, they come in and they respond, look, Francois, I am here because I want to pass the certification. So if this is like a Network Plus, in this case, it's Network Plus, they will respond something like, okay, I'm here because I want to pass the CompTIA Network Plus. And I always tell them, you are in the right place. But what I like to do with my classes is that I like to give you more than just helping you pass the certification. And a part of the reason is when I got started in cybersecurity or, in IT in general, I took a lot of certifications, as you just saw. And many times that was the end goal. It was like, let me study so I can pass this. Then I'll pass it. And then I never use it. It just becomes just a piece of paper that have my name written on it. And part of the reason is because I didn't have any mentors back then, right? There was nobody to guide me to tell me, look, Francois, let's do this, let's do this, let's do this, right? So I used to just be Googling stuff. I Google something. If Google says the certification can help me make more money, I'll take the certification. I will study for it and then take it. Then once I pass them, start listing that on the resume, that kind of stuff. I don't want you to go into that same experience because I'm here not only to teach you past the Network Plus certification, but also mentor you, give you that mentorship that I never had. Anyway, so I'm assuming you're here to understand what the world of IT and computer networking is really all about. And this is really important because as you learn about IT and networking and things like that, you will pass the Network Plus. Now, the way the class is designed, it will help you pass that class because we do have the lessons, which is me running my mouth, but we also have the quizzes. So every section have a quiz, which I encourage you to take the quiz. And that quiz is me kind of trying to see how you're doing with the material, if you're understanding the material. But not just that, the way those questions are worded, it's really the way CompTIA asks their questions. So we're going to talk about that in more depth in a minute, but I just want to, point that out from the beginning. Now, yes, you're going to pass the exam, but I want you to get more out of this class. I want you to understand what this whole thing is all about. But the primary goal is to help you pass the Network Plus exam, which I'm hoping that's the reason why you're here. So over the years, I've seen people coming on, learning things, and they never, take the exam. They never took the exam. They never finished the course. Well, I don't want that to be you. You can easily do the Network Plus in about 30 days. Easy. Or in about 2 months, max. If you start going over like that 30 days mark, that 2 month mark, then that means you're not doing this right. And that means you are kind of making it harder for yourself. Now, I understand that people have life, they have, other priorities, sort of like taking place. But I want you to know that if you are going to be taking this serious, get it out the way. So everything else should be secondary, unless those things are necessary, unless if it's just, family, going to work and things like that. But your parties, you're having fun and things like that, you should put that on hold. You will come back to it. Just put that on hold so you can get this out of the way. Again, this is because I've seen people spending like it been a whole year. You're studying for a certification and you haven't taken the certification. Like, I don't want that to be you because you'll feel like you're making progress, feel like you're part of something, but you're not because like you're investing a little bit of time here and a little bit of money, but you're not getting the results that you're looking for. So let's be serious. Let's focus on it and just get it out the way. I like to tell people you don't have to be a genius to understand network, but you got to put in the work. I'm a highly believe in putting in the work. I didn't share my whole story, but I came into the US in 2008, and came here not speaking the language, right? I didn't know how to say hi, how to say good morning in English, right? So, yeah, I always tell people if I can do it, I believe anybody else can. So I start off learning the language, right? I'm still learning, but now I'm to a point where in the next year or so, I will be getting my PhD. So if I can do it, anybody can, but that require you to put in the work, right? Anyway, you might have to learn things that you don't think they're relevant. I don't think that's going to be the case with the Network Plus, but you might learn things where you're like, oh my God, will I ever use this in a real world? And you will be right, because when I was learning this, there were some things that I learned where all over the years, I never used it. For example, the OSI model, OSI model. I will be teaching you what the OSI model is. But I haven't really been in a situation in my real world where I'm like, ah, well, that's how so that's what the OSI model was trying to tell me. That hasn't really not been the case. I will teach you all of that and more because remember the primary goal, it's gonna be on that exam. And if you're gonna be taking that Network Plus exam, highly recommend you put in the work to try to know all of it. Now, some people are like, okay, why do that? Why should I, become Network Plus certified? Well, I used to be giving advices to people that like, just learn. I mean, these were the people who are trying to get into cybersecurity, by the way, not just anybody. People who are trying to get into cyber. I used to tell them just learn the networking concepts, and you don't have to take the exam. And I think that was okay advice, I guess. But over the years, I have changed my thought around that. And my thought now is if you're in the situation where you're going to take that exam, take the exam, right? And in this case, you should take the exam. Why? Because not only you can list that on your resume, your employees do value certifications as a proof of the skills. So if you're going to be looking for a job that requires some networking skills, having the Network Plus certification proves to them that you got the skills they're looking for. But also, Network Plus is like a stepping stone for a higher certification. So if you're going to be going for things like Security Plus, CISA Plus, Security X, Pen Test Plus, Cloud Plus, and these other pluses, a certification from CompTIA or any other kind of a certification vendor, the Network Plus will help you. The Network Plus will be that stepping stone for that kind of things as well. Let's talk a little bit more about this CompTIA Network Plus exam. Well, unlike vendor exams, exams like the Microsoft exams, the Cisco CCNA, kind of a certification exams. Well, CompTIA, it's a vendor neutral exam. Specifically, it's a vendor neutral kind of a company, and the Network Plus is no exception. So Network Plus is a vendor neutral exam. What that means is that I will be teaching you technologies from all the vendors, right? Unlike when you take the Cisco CCNA, they're going to focus on their routers and their firewalls and their switches and all their technologies. But in this exam, which is I highly recommend this one, in this one, we will be talking about all kind of vendors, Juniper, Cisco themselves, and all these other vendors that do networking type of stuff. So about the exam, you're taking the latest and the greatest. This is the N10-009. That's the exam code. You will have up to 90 multiple choice questions on the real exam. Again, keyword here, it's up to 90. More likely you will have less. All the people who've taken this exam, they'll probably have gotten like 60 questions, 70, 80, right? Like 80 plus questions. I remember when I took mine, I think I got like 78, questions. Anyway, so up to 90, they're not going to give you more than 90. Most of the questions are going to be multiple choice, but you will also have what we normally call PBQ. PBQs are the performance-based questions. Performance-based questions are like hands-on type of questions where you're dragging things in different locations. Okay, I will teach you these as well. So we're touching up on this because if you don't know the PBQs, then it's really hard for you to pass the exam. CompTIA is going to give you these at the beginning of the exam. So as soon as you start the exam, poof, PBQs pops up. And you will get about 3 to 7 in many cases, right? 3 to 7 PBQs on the real exam. So I want to make sure that you prepare, make sure that you understand PBQs and how CompTIA will ask those things on that exam. You have 90 minutes to take this exam. So imagine if they give you 90 questions, 90 minutes, you can see how people start stressing out. One of the biggest reasons why people don't pass this exam is because they run out of time. Yeah, like over the years, I've taught thousands of people on how to pass these exams. And one of the biggest thing that always comes back is like, oh, I spent too much time on the PBQ. I was reading the questions slow. I'll give you tips and tricks on how to pass this exam, right now. But I just want to make sure that you understand that the time is very important. But with this training, you will be prepared right, and you should be able to pass that exam with no problem. The passing score is 720 on the scale of 100 to 900. What that means is that when you register for that exam, you automatically get 100 points. And as you're going on and take the rest of the exam, you're fighting for that, 620. Okay, you're fighting for that 620. CompTIA really don't share this with us, so we really don't know how they go in and do the scoring. If you were trying to ask, oh, well, does that mean I get 1 point per question? We do not know. One thing that we know for sure is that your PBQs have more points than regular multiple choice questions, because your performance-based questions, PBQs, they might ask you to do about 10 things, like 10 different tasks that you do. You drag something here, then you select, you pick, you choose, you do all kind of things. So it's kind of safe to assume these weight more, and that's true. Now, CompTIA recommends you have some kind of experience. Now, before you get into the networking, they kind of say, okay, you should have about 9 to 12 months of either networking or IT experience. That's recommended, it's not required. Okay. Basically, all they're trying to tell you here, you should have your A+. Now, if you came here without A+, well, it doesn't mean you can't take this. We do have an A+ class on the platform. Maybe you should check that out if you're completely beginner. But most people should be okay with just Network Plus, because the thing about A+, all you're learning is hardware and software. So if you've never touched the window, then probably, go with A+. But if you know what a computer is, a computer monitors, the computer case, the hard drive, the CPU, central processing unit, the RAM, random access memory, motherboards, and hard drive, and things like that, then you should be okay to move forward with the Network Plus. Okay, but if you completely begin, I highly recommend you start with A+, then jump into the Network Plus. And if you don't even know if this thing is for you, IT, cybersecurity, networking, if these things are for you, maybe go with the Tech Plus. Right? Tech Plus first to assess to see if, any of one of these topics are really interesting to you. Then after that, get into the A+, then after that, get into the Network Plus. Anyway, you're here, so let's keep going with the Network Plus. Now, this is designed for people who are maybe high school students, those people who are entry level, those people who are doing IT, help desk, network and system administrator, right? Basically, anybody who's interested in learning about networking, they're welcome to join this class. So how do you go in and take this exam? These are the frequently asked questions. So some people are like, okay, where do I go to schedule the exam? Well, you do that from the Pearson VUE. This is a different different company that CompTIA works with, where you will have to schedule that exam, usually by yourself. And the CompTIA have made this a lot easier now, because all you do once you sign into your CompTIA platform, then there's an option there that says a schedule exam. You click on that, you click on the link, it takes you to Pearson VUE, then you schedule your exam there. Now, as you're scheduling the exam, you can decide to take it from a testing center or take it from home or from the office, really doesn't matter. I recommend you take it from a testing center because I've taken some exams from home and the people, the proctor, the people who watch you as you take the exam, they're not that friendly. So take it from a local testing center if you can. Now, what should you bring as you're taking this exam? Well, two forms of ID. Your driver license should be one, which have your picture on it, but you should also have anything like a credit card, a debit card, anything like that have your name on it. It doesn't have to have your picture, but it must have your name on it. So how this exam is administered? Well, if you take it from a testing center, they would take you, have you into some kind of location, a room where there's going to be a camera that's is going to be watching you as you're taking the exam. Okay. And when you're done, they're going to print out your results. But as soon as you get there first, they're going to kind of take everything away from you. They're going to put that in a locker, lock it, give you the key, and then let you go take the exam. If you're taking it from home, it's a little bit different because you must have a camera. That's one. And the other thing is the proctor, person who's going to be watching you, they're going to have you kind of show around the room, making sure you don't have any sticky notes or anything like that. But when you take it from home, you cannot read the question aloud. There's a lot of things that you cannot do when you take the exam from home. So how soon after you've taken the exam, after finishing taking the exam, you will know that you've passed it? Well, it's going to be immediately. That's the beauty. I remember like years ago when people were taking some of these exams, like the CISSP and things, like you would take that on a pen and paper, and then you have to wait for about 2-3 weeks for you to know if you've passed or not. And I tell you, those 3 weeks, they were the longest, the longest. So, but now they made it easier because everything is through computer. As soon as you finish taking the exam, they will tell you if you've passed or if you've failed. So basically, you see the congratulations or you see sorry. And you should be looking forward to that congratulations wording as well. Now, if you don't make it, if you don't pass the exam, well, what's going to happen? Well, you can retake it. Can you retake it immediately? Absolutely. You don't have to wait for the Network Plus. Okay. Like I said, you will have a multiple choice questions that have a single answer. Some of them, not so many, might have like a multiple answers where they give you like 6 different options or 5 different options, and they ask you to pick 2 different multiple choice answers. Okay. Now, I did mention about the PBQs. These are the hands-on that will give you the practical skills. So we will be talking about those in this class. Now, when you take the Network Plus and passed it, what are some of the jobs that are you qualified for? Well, in practicality, you can apply for any one of these jobs that are listed here. We do have a section like at the very end where we'll talk about like networking careers. So maybe check that out for additional information about this. But you can apply for network administrator, network technician, help desk, IT support, system admin, entry-level cybersecurity analyst type of roles. Again, but I highly recommend Network Plus should not be your finishing line, right? This should be your starting point. You should, try to get, better upper level certification. And what are some of the tips for taking this exam? Well, it's simple. Read the question. Oh yeah, people who fail this exam, sometimes it's because they think they understand the question, but they didn't. So they skimmed the question. They're not taking the time to read the question thoroughly. They're skimming through it, and they're like, oh, I know what the answer is. No, you don't. So take your time, read the question in its entirety. Don't just read a few words and assume that you understand what the question is asking. And a part of the reason is because CompTIA questions are subjective. They will ask you a bunch of things, or they will put a lot of things at the beginning, and towards the end, they're going to say, oh, which one of the following is the best, and which one of the following is the most way of doing this. And the reason why CompTIA does that, I think it's to try to trick you. But the other thing is, they will have like multiple answers that look like they are the best answers. Basically, all I'm trying to tell you is that if you didn't read the question in its entirely, you might think you know what the question is asking, but towards the end, they're telling you we're looking for the best answers. And the 2 of those answers, they're like the best in your mind. You're like, oh, that should be the best. Oh, no, this one should be the best. Well, that's when you do the process of elimination. Process of elimination is when you look at the answers and you're like, you know what? It's definitely not A. It's definitely not B. And then you're left with just two choices, C and D. And then you're like, out of C and D, which one is the best? Then you pick the one that is very, very best. Okay, so process of elimination, eliminating any answers that you know for sure they're not part of the exam, they're not part of the question. And then if you're left with just two choices, it's a little bit easier for you to even guess. If you're making an educated guess, it's really easy for you to do that. Speaking of guessing, do not leave any questions unanswered, right? It's okay to guess. That's absolutely okay. Just make sure you've read the question once, you read the question again, make sure you understand it before you can guess. The other thing is, if you are really stuck on any questions, right, don't just stay there. Keep staring on that screen because the timer, the time is going to be like in your right hand side here, kind of keep going down and down and down and down. It's yeah. Anyway, so if you get stuck on one of those questions, you can flag it. There's a little flag there somewhere. You just click on it and it's going to flag that question, which is going to make it easier for you once you come back and review the questions. Once you finish, you can come back and be like, oh, this is the question I was struggling with. And I find that really good because as you're going in and you answer all the other questions, well, there's some other questions you might get to that's going to answer the question that you skipped. That have happened to me before where I wasn't sure what the answer is, but as I progress forward with the other questions, another question comes up with that kind of a reboot my mind a little bit. I'm like, oh, so the answer to the other one should have been this one. Yeah. So what I do, I usually just go back and answer it, or just wait towards the end and then click on the flagged questions so you can be able to answer those as well. Now, as you study, prepare a short review sheet. You should do that, ideally for the things that you are having trouble remembering. So again, I'm a huge believer in note taking. You should be taking notes. Huge believer in note taking. So write it down things that you're struggling with. And once you go take that exam, I recommend you go there early, preferably 30 minutes early. And once you get in the parking lot, stay there in your car for a little bit and look at your sheets, right? Look at the review sheets. Look at the things that you're having trouble remembering, right? Look at your study notes, if you will. Take about another 10 minutes, 20-minute review over those things. Go over the questions that you're not understanding. Go over the ports that you're having trouble remembering, all that stuff. Now, once you get into the exam taking, once they finish kind of authorizing you, they will give you a scratch pad. It could be just a piece of paper and a pencil or a pen, or a scratch pad and some kind of a marker. Well, what you do then, you're going to write it down before you start the exam. You're going to write it down, all the things you remember from your review. Absolutely. You are okay to write anything down. As long as it comes from your head, it's okay. So just write it down and write it down. Kind of empty your mind so that you are very, very relaxed. Now, as you're getting ready to take the exam, I find it really helpful to take a deep breath, especially this is your first time taking the exam. You might be stressing out. And over the years, I've come across students who fail the exam not because they don't know the material, no, because they were very stressed, because this was their first time taking an exam and they're like, I don't know what to do. I don't know. No. Take a deep breath. If you feel like once your heart starts beating fast and you feel like, no, relax. Know that you're prepared. Know that you are going to pass the exam. And keep telling yourself you're going to pass the exam. What I do, and I find it really fascinating, is on that scratch pad, I will write, I will pass. Literally. That's what I just read it there at, towards the end after writing down the things that I remember. I just read it that there. So I'm, as I'm taking the exam, I'm looking at that. I will pass. I will pass. I will pass. So that positive affirmation. Once you are certified, you got to keep your Network Plus in good standing, right? I've had people over the years who let these exams kind of expire. You don't want that to be you, right? This Network Plus is not the test that you want to keep taking over and over and over again. The beauty of this is that there's multiple ways for you to renew your Network Plus. So your Network Plus will expire every 3 years, and you can renew it using a single activity. For example, you can go to the CompTIA website and take the Cert Master Continuing Education. That's what that stands for. Cert Master Continuing Education Training. It's about 7 hours training. You take that, they're going to give you an assessment, some kind of exam. Once you finish taking the training, you take that exam. Once you pass that exam, then you're okay. Your Network Plus will become certified. I mean, you will become renewed. So then you don't have to worry about it for the next 3 years. So some people do that. I don't do that. And part of the reason why I don't do that, like I said, I like to keep studying. So what I do this second option. So I take the upper level certification. The beauty of CompTIA certifications is if you take the upper level certification, they're going to renew your lower level certification. So if you 2 years from now, you decide to take Security Plus, it's going to renew your Network Plus. 3 years after that, you decide to take your CISA Plus, it's going to renew your Security Plus and your Network Plus. So that's what I've done over the years until I get to Security X, which I took about a few years ago. And I think it's expiring next month. It's expiring next month. So I need to renew Security X. And once I renew Security X, it's going to renew all these other things as well. Okay. So that's another way. The last way is by obtaining 30 continuing education units, CEUs. And there's a lot of ways that you can obtain these. And you got to obtain these in 3 years, right? Basically, every 1 hour you spend studying anything, you get a CEU. As long as you can prove to CompTIA that you did spend that 1 hour. So if you get like some kind of a certification of completion, you can submit that to them and they're going to give you like one CEU. Like every hour you spend studying, you're supposed to get a CEU. Okay. So how can you get these? Well, you can earn CEUs in a lot of ways. One, by going to some kind of a security events. If you go to things like ShmooCon, DevCon, right? RSA security conferences, really any conferences. It could be virtual, it could be in a physical setting. It doesn't matter, right? You go there. If you were there for like 20 hours, you get 20 CEUs. If you take some kind of online courses, like this course that you're taking right now, if you want to renew your Network Plus or your A Plus, you can use this course to be able to renew that. Okay. So you go to our webinar, seminars, SANS. This is an institution that is really respected when it comes to cybersecurity training. They do have a lot of webcasts that you can take, and they will give you like a completion certificate, and you can submit that to CompTIA to get those CEUs. What I recommend though is go to conferences, attend the security conferences, attend networking conferences. And a part of the reason is not only you're getting CEUs, but you're also networking with people. So go to these DEF CON, ShmooCon, Black Hat, RSA, you name it. Go to these so you can be able to network with people, shake hands, introduce yourself, tell them I'm new, I'm getting started into this industry. Any tips, tricks, advices? Are you hiring? Literally, right? The hiring managers are there looking for the people to hire as well. Right? So if you read an article, books, if you taking courses on campus, a university, you get CEUs, right? If you're a member of some kind of association like ISACA chapter or ISC Square chapters, you also get CEUs for all the activities that you participate in. There's a lot of ways to renew this. Do not let it expire, because when it does, it's not the test you want to keep taking it over and over again. One of the things that you're going to get out of my class is I try to emphasize practical. Practical skills are important because what we do in IT and cybersecurity is applied science, right? You can't really book smart your way to the top. You can't memorize a bunch of things. So what we're going to do in this particular video is to download a tool that's known as a packet tracer, right, packet tracer, and set it up, because there will be a lot of things that we're going to do as a way of practicing the things that you're learning. And packet tracer is a tool, networking tools from Cisco, that will help us do that kind of stuff. But that's not the only thing we're going to do, but we're going to use it for a lot of the labs that's going to be part of this training. So for now, let's go ahead and go to google.com. I'm going to head over to Google, type in google.com. And once you're here, I want you to download Packet Tracer. So type in download Cisco Packet Tracer. This is from a Network Academy. So NetCAD, our Network Academy. Packet, if I can spell packet right, there we go. And I'm gonna press enter. It's a little bit hard to find the download page. They usually just hide that somewhere. So, but let me see if I can find the link here. And it looks like I can't find it. So guess what? I'll put the link to the download in a section, because when you Google this resource hub, they basically tend to be hiding that. Let me go back here and just add resource hub here. Let's see if they're gonna bring that up. And it looks like it's still hidden. Yeah, it's still hidden. Let me see. No, that's not even the link. So what I will do, I'll put the link to this in this video description. So you can click on that link, then it will take you to this location known as a resource hub. And you can download it there as well. I don't know why Cisco does this. It's a nightmare to try to get to download the packet tracer, but they made it free. We thank them for it. They should just make it a little bit easier to be able to find the link. Anyway, once you get here, packet tracer is going to be down here. And this is the Cisco packet tracer. You can download it for your Windows as well as for your Mac. All you need to do is just set up an account, a NetCAD account. So before you download it, just go ahead and click on sign in. And then once you click on that, click on sign up. You can also sign up with Google, or just, create your account. So I'm gonna go back here and sign in with my account. So type in my user account here. And go ahead and put in my password there, sign in. Now that you're signed in, scroll down again until you can see the packet tracer, and then click on the download of the operating system that you're using. I'm using Windows, so I'm gonna click on download for Windows 64-bit. It's going to take me that into my downloads folder. I'm going to go ahead and save that here. I'm going to click on save. Okay. After you've saved that there, I'm going to go ahead and bring it this so you can get to see it. This is it right here. All you do, double click on it. And then the installation wizard is going to pop up. Then we're going to get into the installing packet tracer as well. But make sure you set up the account for your NetCAD Academy as well. All right, there's a pop-up here that says, okay, you sure you want to do that? It's a yes or no. We're going to say yes, we want to download packet tracer. Okay, and there is the wizard that I was talking about here, the setup wizard right there. Okay, just if it doesn't pop up, just click on that, then it's going to come here. Right now, they're asking us to agree to the terms. I'm going to go ahead and click yes, I agree. Then click next. They telling us where we want them to save this packet tracer in that program file in the C drive. I'm going to say, yep, that's okay with me. You want it to be saved as that name. I'm going to say, yep, that's okay by clicking next. Then, go ahead and create the shortcuts for the desktop, but also for the quick launch, this right here, so that they can put the shortcuts, the logo, packet tracer logo there as well. I'm gonna make sure these two are selected, click next, then I click on install. All right, so give it a minute for the packet tracer to install. It should take about just 1 minute. It's not a long program, so I'm gonna wait. When that's finished, we will finalize this, and that's it. And after waiting for a little bit, it looks like packet tracer is done. Now there's this launch packet tracer automatically. It's selected. I'm going to click yes. Let's go ahead and finish this. Click on finish. And they're thinking, all right. trying to launch a Packet Tracer. But before they do that, they're like, okay, would you like to run this as a multi-use? I don't mind. I'm the only one using this machine. So I'm going to click on yes. And here we are, right? It's bringing up Packet Tracer for us. And this is Packet Tracer, right? So when you run Packet Tracer for the first time, they're going to ask you to sign in. So the account that you created, the Network Academy account that you created, I want you to sign in for as a skills for all. Right? Don't sign in as a Network Academy. For some reason, I find it, there's some issues with it. For some reason, I don't know why. But go ahead and sign in with a Cisco for all. And then when you click on that, it's going to take you back to the website. I'll try to get you to sign in. In our case, we're already logged in automatically. So it's just not going to do anything. It's just going to take us back to Packet Tracer and sign us in automatically. And now we do have Packet Tracer up and running. Right? It's important that you do sign in, because if you don't, it's not going to work. Now, this is the tool that we're going to play with. This is the tool that comes with a lot of the things that we're going to be learning in this Network Plus. So be sure to set this up and make sure you have it running. For example, you have all the networking devices here. When you click on that, you got things like routers, switches. Let me go ahead and zoom in. I'm going to click on options, go ahead and go to preferences. And right here, I'm going to go to font. I'm going to go ahead and push that to maybe 10, maybe 11. Click on apply. There we go. I'm going to close this. Now you can see this a little bit better. So if I click on the network devices right there, you can see I have all the routers and they're right here. And then I have all the switches right here. I can have the really right here. Then I have the hubs. Nobody ever uses hubs anymore, but we have a wireless devices. And we also have a security devices, but here's the kick. A lot of the things that we have are Cisco product. For example, when you look at the switch, the 2960 is one of those classic switch from Cisco. And the way you added that, let me go ahead and remove that. Click on delete. All you got to do, you pick it, and they're going to kind of have that sign like that. Then you click somewhere on this white space there like that. Then they're going to add that particular thing. Okay. So let's say you want to add computers, where you go to end devices. Then you have your end devices are selected there. You have your PCs, your laptop, your servers, your other things here. So you click on the PC, you click it here. You click on the laptop, you click it here. Okay, let's say you want to connect these things. You go here, you pick the cable. Now we will be learning all these cables: the console cable, the copper straight through cables, the crossover cable, the fiber optic cables, and all these other ones. But if you want to pick the automatic cable here, you just click on the flash icon. Then you can pick which devices you're trying to connect it to. Again, you don't have to be doing what I'm doing right now. I'm just kind of showing you this as an example here. Okay, there we go. So I connected these two computers together. Now this thing is not working. So I'm going to click back on that. There we go. And this is actually interesting because these are two SAM devices, they're connected using this crossover cable. When you're connecting like two things that are the same, like a computer and another computer, they're going to use that kind of cable. If you're connecting things that are different, they're going to use a copper cable as well. Okay, I'm getting ahead of myself. We have a lot to talk about, but just make sure this tool is up and running, because we will be using this tool for a lot of the labs that we're going to do in this class. Welcome to part 2 of this lab, this Network Plus lab setup. Now, once you're done with setting up Cisco Packet Tracer, which we're going to use that for a lot of these networking labs, I want you to also set up a few more things in order for you to get that practicality that we need. Okay? So in this lab setup, this part 2 of the lab setup, we're going to do one thing: set up a VMware workstation. So this is why we don't look at a hypervisor, VMware workstation. This is a hypervisor, which is it's a fancy way of saying is a tool that you can use to install computers inside another computer. It's what we call a virtualization. You're virtualizing your computers. For example, I'm running Windows right now, Windows 11. Now I want to be able to run Kali Linux, which is like a Linux distribution of Kali, or known as Kali. So I want to be able to run that on top of my Windows 11. What do I need? I need a hypervisor. I will teach you all this in this class. So in this case, we're going to use that tool, this hypervisor tool, that is known as a VMware workstation. So I will show the first part of this. It's me showing you how to install this. Second, we are going to add Kali Linux on top of this VMware workstation. Okay. And this is going to help us with a lot of things. For example, if we want to assess the OSI model using something like Wireshark, well, that's in Kali Linux. And then we can just spin up the Kali and then so you can see this in the practicality. Again, guys, I want you to get as much of a hands-on that you can get. So part 3 of this, I want you to install another VM that's known as a Metasploitable, which I'm about to show you how to do all this right now. But this is a system that I usually just call Meta, but it's Metasploitable. It's a vulnerable machine that is weak. So as we're going in and doing our network and configuring networking and networking IP addresses and routers IP addresses and things like that, you might scan Meta, you might ping Meta, you might do the kind of things we do in networking. So that's why we're going to add this system on top of a virtual VMware workstation, so you can have like a complete setup. Now, few caveats, specifically with the first one. The other two, we're going to dive right into it right now. VMware Workstation is already installed on top of my computer. Let me bring it up here. This is the tool that I am talking about. This guy right here. Okay, this is a VMware Workstation right here. So as you can see, I have a couple of labs already set up. I have some virtual machines already running on top of a VMware Workstation. So I'm not planning on removing this. What I will do for this first part, I will show you how to download it. I just didn't want to tell you, hey, just, download the VMware Workstation. It's actually hard for you to kind of finding the download link, but I'll show you all that in a minute here. But what I will do, I'll bring in another clip that I already recorded about downloading VMware Workstation. Then from there, I'll do all this into editing stuff. From there, I will come back and then we will add Kali Linux, right? And the Metasploitable on top of this. We'll create a different folder. I'm actually going to do that. I'm going to click on my computer here, create a new folder right here. And let's call this Network Plus Lab Setup. Okay. Just going to call that Network Plus Lab Setup so that all the virtual machines, the new Kali and everything else is going to be added inside of this folder right there for us. Anyway, so let me show you a few things. So I'm going to exit out of here. What you're going to need, you will need to go to Broadcom.com. And once you're here, click on portal support so you can create an account. So you click on support portal and then I click on register. You're going to register for an account. Just email, it's going to do just fine. Email and passwords. Once you finish registering, you are going to need to click on a link, which I'll put this in the description as well. I'll put the link that you can just click on, because Broadcom is a huge company. They have a lot of products. So look at this. They have a lot of things. It's really hard for you to find the download link, but they wrote a blog post here making Workstation free. It used to cost money. Workstation is from VMware. Broadcom bought VMware, and they made Workstation free. Woohoo! Thank you, Broadcom, right? But I'll put the link to the download in the description of the video, so they can just click on this link, right? And then I get to the download. Actually, I will have the actual link that you click on, then it takes you to where you go in there and start downloading. So once you're here, depends on what you're using. If you're using your Mac, go ahead and grab Fusion. But if you're using Windows, which I am, we're going to grab the Workstation Pro. So click on here. And if you don't have an account, Broadcom is going to direct you to a page where you need to set up your account, right? But I've already registered the account, so it's redirecting me to the download page. So once you're there, you see where it says Workstation Pro. Again, if you don't have an account, set up that account first. Then there are some things you have to agree. I find it really tedious. with these guys. Hopefully, they're going to improve their processes. Anyway, so VMware Workstation Pro 17 for personal use. Click on that, and then let's grab the latest, the 17 version. So I'm going to click on that, and it's thinking. Then once we're here, looking good, I'm going to click on downloads. And then normally it will ask you to agree to the terms. Right? When you try to download it from the first time, there's like a little thing here that says, hey, you got to agree to the terms first. So you do that first. All right. So I'm going to put this in a downloads folder. I'm going to save that there. And when this is done, we're going to go into the process of installing, VMware Workstation Pro. And it should be done. Oh, it's almost done. All right, give it a minute. And there we go. It's done. All right, so I'm going to double click on this, or you can go into your download folder and double click it from there. Double click on that. And we'll get into the process of installing Workstation Pro. There we go. Here we are. There's a pop-up that says, hey, you sure you want to download this? I'm going to click on yes. There we go. And let the party begin. It's getting into the whole downloading process. So let's do exactly just that. There we go. Perfect. All right. Now, this is the setup. We're going to click on next. And I say, hey, you sure you want to do that? Go ahead and agree to the terms. I say, yep, next. And they're going to kind of ask if you want to add this enhanced keyboard driver. We don't want to do that. We will click next. And then do we want this to be updated automatically? Say yes, click next. Do we want the shortcuts to be added to the desktop? We're going to say yes, click next, and then click on install. So basically all you're doing is yes, 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 and then you click on install, right? Really straightforward stuff. So give it a minute for this whole thing to finish installing, and then we're going to move forward with the rest of the lab. All right, here we are, and it's asking us to finish. So we don't need to enter a license or anything like that. So just click on finish. And this is done. So I'm going to go ahead and open it up, and I'll just search for VMware. There we go, Workstation. I'm going to click on that. And if you open it for the first time, it's going to ask you, oh, hold on a minute. You sure you're not using this? This is not for commercial use? You're going to say, no, it's not. So it's for personal use, therefore it's free. Yeah, pretty good stuff. So I'm going to click on continue, then click on finish, and voila. All right. Okay, so after the installation, you are here. Hopefully now you have a VMware workstation up and running. Yours is not going to have all this stuff. It's going to look clean. Okay. Now, first of all, let me go ahead and just rename this Network Plus that I created earlier. So I'm going to right click on it and then click on rename. Let's just call it something very, simple. I'm going to just call it Net Plus Labs. All right. Something like that. Something like that's going to do. Let me use lowercase there. Net Plus Labs. I'm going to keep them capital. There we go. There we go. Better. Okay. So all the VMs we're going to be adding, we're going to add them right there. Then I'll go back to the page here and start installing this. Let me go ahead and close this, because I don't need all of that right now. There we go. Let's remove that here. There we go. So go to kali.org. Link is going to be in the description, like I mentioned. Then once you're here, click on Get Kali. When you click on Get Kali, it's going to take you here. Now, once you're here, you want to click on Virtual Machines. Virtual Machines. They will take you to these pre-built virtual machines. Once you're here, they will have few: VMware, VirtualBox, Hyper-V, and so on and so forth. We want the VMware. So go ahead and click on this little icon right there to download it. Then once you're here, go into your C drive. Hopefully that's where you're saving your things at. Go into the C drive. And in my case, I'm going to double click on C drive, and I have a folder here known as a sec lab. I'm going to double click on that. Then I'm going to create another folder here. I'm going to call this keep it the same, Net Plus Labs. Okay. I'm going to press enter after that or click here somewhere. Now double click on Net Plus Labs, then I will add that inside of that location. So click on save so it can start downloading. It's downloading now. Okay. Another tool we need, or another VM we need, excuse me, it's Metasploitable. Like I said, Metasploitable, it's a vulnerable machine and you can download that from SourceForge. Once you're here, click on downloads. Usually when you click on the link, it's going to start downloading automatically. That's what happens. But if it doesn't, just click on the download icon and this is going to pop up like that. So I'm going to go ahead and go back to where I'm saving my things into the C drive, sec plus sec lab, and then net plus labs. I'm going to save that in there as well. Now it's downloading. Okay. One other thing that you might need is a tool that's going to help you unzip those files. So let's go and download the 7-zip. Me, I have 7-zip already, but I want to show you how to download it. I want to make sure that you got it, right? You don't run into any issues. So go to 7-zip or just Google 7-zip. Let me actually go to the home page so you can see this. Go to Google, type in 7-zip, then go to the home page of 7-zip. Once you're here, click on the downloads. All right, click on the downloads. And right now I need the 64-bit right there. 64-bit. So I'm going to click on the downloads and ask me to save this. I'm going to save this into the downloads folder. I'm going to drop that in there. And if I open up my download folder right now, and bring that here, so you get to see it. This is it here. I already have this installed, but all you do, you just double click on this. And there's a pop-up that says you sure want to do that. I'm going to click on yes. And this is it. All I do is just click on install. I think they don't mind me reinstalling this. But it's a really lightweight program. As soon as you click on install, it's going to finish installing this. This is for unzipping file. I'm going to go ahead and close this. Now let's go ahead and check to see if it finished downloading. I'll go to this PC. Let me zoom in here. Let me get this out of the way. There we go. So I'm going to click on this PC, go to local disk, the C drive. I'm going to double click on sec lab. I'm going to double click on net plus labs. Now we have these two. Okay, so the first thing I need here is to open up Metasploitable. I'm going to right click on the meta and then click on more options, show more options here. A little bit weird with the Windows 11. Then once you're here, click on 7-zip or point to 7-zip, and then click on extract here. There we go. That's what you need to do. So click on extract here. Click on that. I'm going to start extracting 7-zip, meaning taking it from that zipped folder right there, extracting it here for us as well. And after extracting Metasploitable, the next thing we need is extracting Kali. So right click on Kali as well and go to show more again. Then click on or point to 7-zip and then extract here. Same way. Give it a minute for this to finish extracting. Okay, looks like we have both of these finished extracting. So let's go ahead and rename these right quickly. I'm gonna right click on that and then again go back to show more so I can bring up the rename. Let's call this meta. Press enter. Now we have meta. Right click on Kali again, then go to show more, go to rename. Let's call this Kali. Okay. Now we have meta and Kali. I'm pressing enter to finish that. So if I would double click on Kali right now, I see a lot of files here. Okay. But the file that I care about is the one that has a different icon, usually the second one from the top. Okay. This is the one that we need to run. So go ahead and double click on this. It's going to go ahead and open in VMware Workstation. Let's go ahead and change a few things here. First of all, let's change the name. I'm going to right click on the Kali right there. Click on, not remove, click on the rename right there. Then let's call this Net Kali. Okay. You can also call Net Plus, but Net Kali sounds good. I'm going to press enter. That has been created. Then I'm going to grab that Kali. I'm going to drop it inside of the Net Plus Labs right there. Now we have the Kali, right, this Net Kali inside of Network Plus. Now, once you finish with the renaming, another thing I want to show you is where you will find the username and the passwords. So down here, I don't know if you can see it, but in the description, they're telling you the version of Kali that you downloaded, but also they're giving you the username, which is Kali, and the password, which is Kali, and a few other useful links there. Here in the devices, you can see the memory, the processor, the hard drive, the network adapter, and so on and so forth. So let's go ahead and change this a little bit because I have enough. But what they have, the default should be enough. If your computer, let's say your computer is a 4 gigabytes of RAM, it's okay to just keep going with what they have here. Okay, but because I can, I'm going to click on Edit Virtual Machine Setting right there. Okay. And when I click on this, they're going to take me to this virtual machine setting tab. Here, I can increase the CPU, the memory. I said the CPU, that's the processor. But the memory here, it's 2 gigabytes. Let's say I want to push that to 4 and just click on 4 right there. It's going to be moved to 4. And the processor, it's 4. I just want to keep it the way it is. Hard drive, I don't want to touch none of that. Now, in the network adapter, we can see that they already selected NAT. This is the network address translation. I will teach you what that is in this class. But there are a few things I want to mention. First of all, when you look at the network connection, you can see that there's this bridged connection. What does that mean? Well, what this means is that you want your virtual machine, in this our Kali Linux machine, we want our Kali to be able to communicate with our physical machine, like in this case, with my Windows 11. So this is good in some cases because that means your virtual machine will receive an IP address from your physical router, meaning the same router, whoever the provider is, if it's the AT&T, if it's the Comcast, they will assign an IP address to this virtual machine. Now, I'm throwing a lot at you. I'm saying routers and IP addresses. I know I haven't taught you all that yet, but I will. This is a Network Plus class. And that's why you're here. Okay? So, but we don't want to do that. So then there's this network address translation. What this is it's going to allow a VMware workstation to work as a router. Again, that word router, to function as a router so that my computer or the computers that are connected to this NAT, network address translation network, can get an IP address. Okay, that's the beauty of this. But you can also do host only. You can do host only, which is good if you want to create a private network where maybe you want to put computers there that won't be able to communicate with anything else. You don't want those computers to get on the internet. Well, then you put that on a host only. You can also do custom, and custom is going to let you pick whatever kind of a virtual switch that you created. This is just like host only, meaning you went over there, you create a virtual switch where you can maybe connect those computers to. And then this makes it more flexible because you can go in there and assign IP address and all that good stuff. Actually, let me show you that quickly. What we're going to use though, it's NAT. Let me put that back to NAT. But let me show you this custom virtual only, what it's all about. So if I click on, it's not going to let me until I click OK. So let me go ahead and click OK to save all the changes. And now we can see all the changes have been saved. If I go to edit, then I go to virtual desktop editor. This is where you can create your virtual switch. I'll teach you all that. But right now I can't because I'm not running this as the administrator, as you can see here. So all I do, I just need to click on the change settings. Then ask me, you sure you want to do that? I'm going to click yes. And now I have this virtual editor here with the ability to add networks. So I can add a network. They're going to tell me, hey, you want to add that as a VMnet? I can say, okay. I'm showing you this. We're not going to do this. I'm just showing you how you will create like a virtual switch. And then that's the network there. So I can rename that and I can call this, let's say switch 01, SW01, for example. I click OK. That's switch 1. And this is the IP address. So this is where it's flexible because now I can change this. I can literally go in and just say, hey, this is going to be on .10.10.10.10.0 network. Then I can specify the subnet mask. I can even go to the DHCP settings and specify, okay, what's going to be the very first IP address this thing needs to assign. Again, I'm throwing a lot at you. DHCP, IP addresses, subnet mask. What is it? Well, I'm showing you all these things at the beginning, because once we get to the actual content and we're talking about this, you're gonna be like, oh, that's why he was showing me earlier. So I'm gonna close this, go ahead and remove this SOW, remove that switch one. No, not renaming it. I want to remove it. There we go. It's done. I'm gonna click on cancel that. So now we have net Kali. Let's go ahead and bring in the other machine. I'm gonna go back to my labs here, my net labs folder. I'm gonna click on Meta, and inside of Meta, I have the SAM files now, and I have a file that looks unique, the icon, and double click on that. It's going to open in Meta. It's going to open in VMware Workstation. I'm going to right click on that. Let's go ahead and rename this to Meta. There we go. There we go. Excuse me. Let's go ahead and drop that in Net Plus Labs. There we go. Now we have Meta, we have Kali. Let's see, as far as the memory goes, we're not gonna really do a lot with this. Let's leave everything on default. Okay. And the other thing I should have mentioned here is the username and password of this thing. So right here, let me click somewhere else. There we go. So right there, you can see that they said the default login and password is MSF admin, right there, MSF admin, and the password is MSF admin. So write that down. The username of Meta is MSF admin, and the password is the same. Okay. Once you finish setting these up, you're done. Both of these are okay. Let's go ahead and power them and then ping these and making sure they're up and running. So they're going to ask you, hey, did you move it here? You copy it here. Just click on I copy it here so that it gets a unique MAC address. Ooh, I'm throwing a lot at you, but I will be coming back to all that. I'm going to click on Net Kali, and we should call that Net Meta. I'll change the name to Net Meta. So it'd be kind of nice. So click on Kali and then click on this play icon or double click on it to power it on. And then when you power it on for the first time, that's where that pop-up comes up asking you, hey, did you copy it here? Did you move it here? Okay, just like what they did with the Meta. But it looks like they didn't ask that on Kali, which sometimes they do not. Okay. So let's give it a minute for these machines to boot up, and then we're gonna ping them, meaning we will see if they are communicating with each other, and that's going to be done for this lab setup. There we go. So Kali is up. I'm going to sign in with Kali, the username. And the password is Kali. Let's go to Meta, and Meta looks like it's up. Then the other thing you need to know, Meta is just black screen. You don't really see much here. But I'm going to click here somewhere, and your mouse is going to disappear. That's okay. And type in MSF admin, press enter, then type in MSF admin again, press enter again, and now we're in. How do you know you're in? For that $sign. All right, as soon as you see the $sign right there, my keyboard, let me see if I can get the keyboard back. There we go. There we go. That $sign right there is showing you that you have already logged in. Yeah, okay, well, what if I want to find out what the IP address of this thing is? So all you do is just type in if, let me press there again, and type in if config, right? if config. I'm going to press enter. Let me get back my mouse here so I can show you this. There's ETH0. This is our interface. I'll teach you what this is. Then you have the iNet here, and then it's telling you the ADDR. That's the address. It's telling you it's 10.0.0.14. .14 is this Meta's IP address. Okay, net Meta. I'm going to change the name. let's go back to Kali and let's figure out what the IP address of Kali is. I'm going to press on the terminal here. Okay, and I'll go ahead and zoom in because I can in Kali. And right now I can type in the same thing, ifconfig, but let's use the new guy. It's called IP with A, IP space A. ifconfig is old, IP is replacing ifconfig. That's why I'm showing you both of them. So I press enter, and IP with the A is coming back, is showing me the interface, Ether0. Usually this is the common name for the interface on Linux machines. Then it's coming back, is telling me your INET, meaning your IP address, is 10.0.0.17. Okay, well, let's see if these two are talking to each other. I can type here ping, P-I-N-G. I will teach you what this is. Then I can put in Meta's IP address. If I go back to Meta, you can see that IP address ends with 14. All these three numbers are the same except 14. So go back here, it says, hey, reach out to 10.0.0.14, meaning check with that, see if that guy is available. And let me go ahead and just say, hey, do that. Let me not confuse. Let me just press enter. It's going in, it's pinging. I'm going to do Control-C on the keyboard. Control-C on the keyboard to stop the ping. Okay. What I wanted to do earlier was just to put a control, like count up to 4. That's what I wanted to do. -C with the 4, press enter, so it can just ping 4 times, then stop without me doing Control-C. That's what I wanted to do earlier. Then I thought maybe I would confuse you. But anyway, so right now, these machines are talking. You're like, oh, hold on a minute, so well, how do you know? Well, I can see on the first ping, it sends 8 packets were sent, 8 packets were received, 0 packets were lost. So basically it's telling me Kali Linux, Net Kali, is talking to Net Meta. And that's all you need to do from here. I'm going to go ahead and close this. You click on the X icon. I'm going to go ahead and shut these down. I'm going to click on this shutdown icon right there. I'm going to click on shutdown. Okay. And I'll go to Meta and then click on the exit. That also works. Click on the exit. They're going to ask you, hey, you want to power it off? I'm going to click yes, power off. And now we have 2 machines. Let me right click on this. Let me right click on Meta here and then I rename that guy. It's going to let me, there we go. Let's call this Net Meta. I don't like the net in front of it, but we'll see. Maybe it's going to grow on me. These are the names. You can call it whatever you want. It does not affect your lab at all. After you're done with this is all the setup you need. I will see you in the actual lecture. Let's keep moving. We're going to start off with the domain 1, the very first domain from that exam objective. This is the networking concept. So what I did, instead of just jumping into the OSI model, because that's really the first part of the domain 1, it's the OSI model. Instead of jumping into that, I just want to kind of ease you into this networking. So what I did, I put together an introduction to networking, kind of tell you, what is this networking stuff anyway? Where did it come from? From the days of DARPA, when they were doing researches and coming up with things like IPv4, IPv6, coming up with the TCP IP, that kind of stuff. So DARPA is an advanced research kind of agency within the US government. They are in charge of a kind of a super advanced research. And they're the ones that gave us the internet. At the time, it was known as ARPANET. And the internet is a very, very successful network. I just want to put it that, because there's a lot of different networks, and the internet is one of them. So we're going to talk about the introduction to networking, kind of give you a little bit of history, a little bit of background of where we are and how we became to be, so that you can have that as the background. Then we'll dive into the things that's going to be on that exam. That includes the OSI model. So back in the days when they were coming up with these things, they had a trouble trying to understand or try to translate this or be able to teach this to other people who don't understand this. Okay, so how do computers talk to each other? And guess what they come up with? The OSI. right? The OSI, which stands for the Open System Interconnection, right? It's known as the reference model. It has about 7 different references. It goes from a physical all the way to the application. And the idea of the OSI is to help you understand how computers talk to each other. Okay? But it's theory. Right? It's literally designed to make it easier for you to understand what happens when two machines are communicating with each other. But in a practicality, in a real world, we use what we normally call the TCP IP. Right? The TCP IP is what we use, which doesn't have 7 layers. It only has 4 layers. But we're going to talk about both of these in more depth. After learning about the layers, we will dive into the networking appliances and the applications. This is where we talk about the hardware, the networking hardware. So if you've heard about things like routers, switches, firewalls, maybe some IDS, intrusion detection systems, intrusion prevention systems, IDS and IPS, right? Maybe you've heard about things like proxy and proxy servers, load balancers, right? NAS, those network attached storage, or the content delivery networking, or CDNs, access points. You name it, it's all going to be in the network appliances. This is why we highly recommend you go back to networking, because you got to know these hardware that make the networking possible. You can't finish any IT class without talking about the cloud. The cloud has basically taken over, right? The way we used to configure network back in the days has changed. So cloud networking, it's really, really important. So in this section, we're going to talk about things like VPC, this virtual private cloud, or the network functioning virtualization. Because when it comes to cloud, it's all about virtualization. So we'll talk about that and talk about some of the things that you can do within the cloud as you're configuring a network, like a virtual network in the cloud. So we will discuss that and discuss about the private cloud, public cloud, hybrid cloud. And then I finalize this because you can't really talk about cloud without talking about the SaaS, software as a service, right? Infrastructure, IaaS, infrastructure as a service, platform as a service. So all of that is going to be in that section. Again, we're giving you the background. We're kind of getting you ready so they can understand like the next version. If you're going to be taking a network engineering as your job, we're going to be doing a lot of engineering things in the cloud. And it kind of makes sense for you to understand some of those things that are in the cloud. After that, we'll dive into the protocols and ports. This is where it's going to be coming to memorizing things. I always tell people that. Once you start learning about protocols and ports, this is not something that you walk around remembering, unless if you're like me and you're going to be teaching this. So these are the things that we just basically memorize them, right? And that's it. So here we will talk about things like file transfer protocol, FTP. We'll talk about SFTP, secure shell, telnet, SMTP, DNS, right? DHCP, you name it, HTTPs, LDAP, all of the protocols that you need to know for your networking class exams, but also you need to know for your, the industry. Now, I tell people all the time that, well, when it comes to protocols and ports, these are the things you just need to memorize so they can pass the exam. And once you finish passing the exam, you can go back and forgetting these. And the part of the reason is, in the real world, we don't walk around remembering these things, right? This is the stuff that you Google when you are working in the real world. And from there, we'll talk about transmission media and network topologies, right? Network topology, if you've heard about things like mesh topology, star bus topology, point-to-point topology, that kind of things, it's going to be in this section. But without forgetting how data gets transferred. So if, Wi-Fi, wires using, things like coax cables, we'll talk about cable speeds and copper cable. We'll talk about fiber optic cables, literally. So all that is going to be in this section as well. So unless you're going to be doing like physical kind of a networking of things, a lot of what we're going to talk about here, it's not going to apply to you. But again, if you get like a help desk, probably not help desk, but a tech support type of a role where you're going into buildings, you're setting up cables and things like that, well, you are going to appreciate this section. Then we'll talk about IPv4 and IPv6, because once we dive into how computers talk to each other, we can't really finish that without talking about the IP addresses, right? We'll start with IPv4, give you a little bit background of what it is, how it came to be, then dive into the IPv6. Now, we'll talk about different classes of IPv4, because there's class A, class B, C, D, E, as well. So we'll talk about all of those and talk about IPv6, why IPv6 is here, why I think IPv6 is unlimited. So we'll talk about all that there. Then we'll finalize this section by talking about the modern and network environment. See, we can talk about all these other things all day long. And some of these are great. Some of them are just for knowledge purposes. But if you're going to be doing this in the real world, right, how you go by doing it. So here I will introduce you to a couple of things, including one of the things that I like to talk about known as defensible network architecture. Defensible network architecture, it's a concept that that got kind of a famous from a gentleman. His name is Richard Balick. Well, he came up with that concept telling you if you're going to be designing a network, right? Well, that network will get attacked. So how do you design it so that even if it gets attacked, you're able to find those intruders? So we'll talk about that there, but I also want to make sure that you know the latest and the greatest. So here we'll talk about SDN, the software-defined networking. We'll talk about things like ZTA, the zero trust architecture, zero trust network. We'll talk about infrastructure as code. Believe it or not, a lot of the things that network engineers are doing, it involves coding, right? Automation, automating things, creating things like playbooks and templates and things like that. So as you can see, it's going to be a little interesting, kind of talking about the latest and the greatest of the networking space. So domain 2, we don't have a lot to talk about here, right? There's just few things in domain 2. But first thing we're going to dig a little bit deeper into is routers. Just telling you what a router is and what it does is not enough. So we'll talk about the technology of routing technology. Talk about static routing, dynamic routing. We'll talk about all the routing protocols. If you've ever heard about things like EIGRP or OSPF or BGP, the Border Gateway Protocol, BGP. When I was in school and we were learning this, we had people in the class who would say, let's just call this, big girl protocol. I think they were just me. But you try to have fun along the way as we were learning this. But this is the Border Gateway Protocol. Without BGP, there's no internet. This is the backbone of the internet as we know it. So it's going to be really interesting to talk about that. But also talk about how does router select which router to talk to. Then talk about NAT, the network address translation technology that you'll find in all these routers as well. So from there, we'll talk about switching, right? Switch is important. So we'll talk about what is a switch and some of the features that you'll find in a switch, things like VLAN, virtual local area network. What happens if you want to create like a virtual switch? What happens if you want to have some kind of a technology in a switch? So talk about VLAN. We'll talk about 802.1q tagging, the tagging feature of a switch. Or talk about the speed of a switch. We'll talk about different kind of frames that can be transmitted within the switch. We'll talk about jumbo frames. Right? It's all going to be in this section as well. Then from there, we'll get into the Wi-Fi network config. So as you're going in and set up maybe a Wi-Fi, well, there's a few things that you will need to know. Because look, a lot of companies these days, they do their thing through the Wi-Fi. There's not a whole lot of wires anymore. People are using laptops to do their job. So it's gonna here we will kind of dig a little bit deeper into some of the Wi-Fi technology, the different channels that you will use within your wireless, the frequency that you will use, the SSID, the Wi-Fi name, SSID, Wi-Fi name, BSSID, ESSID. Then I'll talk about the authentication. As we're using the Wi-Fi. How do people go in and authenticate? Well, maybe they're using some kind of a pre-shared key. PSK. Maybe they're using some enterprise way of authenticating, right? We'll talk about that and talk about, okay, well, as they're authenticating, they need security. Well, we'll talk about encryption, Wi-Fi protected access, WPA. But I will take you back a little bit and tell you the history of this. But talk about WPA version 2, WPA version 3, and the previous version of this. We'll talk about that as well. Then from there, we're going to finalize this by talking about physical network installation. So if you're going in and set these things up in a company, which is more likely not, unless you are doing like, physical network, IT, physical networking, cabling and those kind of things. But here we'll talk about the man distribution frame, MDF, or the IDF. These are like locations where you can install the switch at the company. We're talking about the rack size, right? If you're going to be adding routers and switches to the rack, where did you put them? We'll talk about the cabling, a patch panel, fiber distribution panel, right? We'll talk about the power, UPS, uninterruptible power supply. We'll talk about if you set these things up in a data center, talk about humidity, the fire suppression, the temperature. All of that is going to be in this section. And that takes me to network apps or network operations. Now, this one, I find it really kind of interesting and fascinating because this domain talks about some of the things that a lot of network engineers and network technicians really don't like to do, and that is documentation. And the reason why I find this a little bit fascinating is because this is the most important stuff that you can be doing when you are network engineers. Engineer or a technician is documentation and documentation and documentation some more. I've been in situations where we had a spaghetti network. I will show you what a spaghetti network is. A spaghetti network, it's when people keep going in to plug in cables and they plug in cables, but nobody keep the documentation of that. Nobody goes in and they label those cables. So we don't know if this cable is going to a computer, to a wire, to a server, to a phone. We have no idea. So network documentation, it's the boring stuff that is necessary. So here we're going to talk about the physical and the logical diagram. How would you go in and keep that up to date? We're gonna talk about the cables and the diagram of the cables, and we will talk about this from the layers, the different layers of the OSI model. So we'll talk about this from the layer 1, the physical layer, layer 2, which is the data link layer. Then we'll talk about that from the layer 3, which is the network layer of the OSI model. So this is going to set us up to the asset inventory, because if you're going to be documenting things and keeping track of things, you have to have an asset. So we'll talk about the inventory of your hardware, your software, your licensing, right? All that stuff is going to be part of this. They'll talk about the service level agreement. We'll talk about the life cycle of things. If something is, we need to onboard stuff or get rid of stuff, all of that is going to be in this section. And we're going to finalize this by talking about change management, right? Change management as well as configuration management processes. And part of the reason is because when we are working in IT, there's a lot of things taking place at the same time. And some people want to do what we normally call shadow IT. We call that shadow IT in cybersecurity. Shadow IT, it's when they go in, they just install something and they start using it without really going through the proper change management processes, without going to the IT team and asking them for permission or asking IT team to install that for them. So we're going in this section, we'll talk about the change management, how people should request changes, they should, how we should track the changes and how we should approve the changes. We're going to talk about set up baselines, be like, okay, this is where we need to start from, all that kind of stuff. As a part of the network operations, we will talk about network monitoring, right? Keeping an eye on the networking devices and to see how they're performing, their metrics. So here we will introduce you to what we normally call NMP, Simple Network Management Protocol. The different versions of this. There's version 1, version 2, version 3. We'll talk about this. We'll talk about the traps, and we'll talk about things like CIEM. We won't dig a little bit, deeper into things like CIEM, the security, information, and event management, because this is more like, cybersecurity related things. But we'll talk about logs. Because if you're going to be monitoring your network, you got to, grab the logs, specifically network logs. So we'll talk about net flow packets. We'll talk about syslog. We'll talk about, mirroring ports, capturing things as they're going to the network. All that is going to be part of this. And this is really important even when you get into cybersecurity because network visibility, network monitoring is important. Every attack that's going to happen at your company is going to come through the network. So keeping an eye on the network and having that visibility of the network traffic, it's very crucial. And that's going to take us to disaster recovery. I always tell people it's not the question of if you're going to get breached, it's the question of when you get breached. Are you ready? Are you prepared? So disaster recovery, it's going to be important for us because they can attack us. And when they do attack us, it could be a disaster. I mean, most of the time when people think about disaster, they start thinking about God-made. There's like a fire or there is a earthquake and things like that, which is true. But there's also human-made disasters. For example, you get hit with a ransomware attack. A ransomware attack is when they attack all your computers and they encrypt everything and they start asking you for some money. And you can't use your computers until you pay them some money. So that is a disaster. Imagine if you're a hospital, you're in a mirror performing a surgery, and then all of a sudden your computers are encrypted. Oh, not good. So disaster recovery, it's important. We'll talk about this. We'll talk about things like the metrics of disaster recovery. So if you've heard about things like minute time to repair, like MTTR, or minute time between failures, or MTBF, right? We'll talk about that here. If you've heard about things like cold site, warm site, hot site, right? Tabletop exercises, all that stuff is going to be in this section. Then from there, we'll get into the IPv4 and IP version 6 networking. So here we will start by talking about the DHCP. If you're going to be assigning these IP addresses to computer, maybe you want to do that dynamically, DHCP, right? Dynamic Host Configuration Protocol. It's used to assign IP addresses to computers dynamically, meaning automatically. So we'll talk about that. And then talk about other things like what is IPv4? What are the different records of these IP addresses from A records, quadruple A records in the case of IP version 6. We'll talk about the different, kind of a bits. We'll talk about how IPv4 is a 32-bit in length. So we'll talk about IPv6, how it's 128 bits in length and all kinds of stuff. So it's going to be interesting here. Kind of discussing the difference between these two. We'll talk about how IPv4 should be out of a business, right? It ran out in 2011. 2011 is when they assigned the very last IPv4, but it's still in business. And the question is why? And why IPv6 haven't really sort of like took off, right? We'll talk about this. And IPv6 has been in the works since in 1990, I think 98 or 99. That's when they start, working on IP version 6. But even today, there's a lot of networks still uses IPv4. Why is that? And then why there's no IPv5? Why there's no IP version 5? So we'll talk about that as well. And last but not least, we'll talk about network access management. So if you're going to be accessing things on the network, well, how you do that? So some people are like, oh, I'm going to just use a VPN. Absolutely. VPN, virtual private networks. Well, what if you are a system administrator and you want to be able to configure systems and networks? Well, maybe you might use things like Jumpbox. Absolutely, that comes in mind. So Jumpbox, things like SSH, absolutely that comes in mind. So all of that is going to be part of this network access management. And that's going to take us to domain number 4. Now, this domain, it's all about network security. So if you end up going for, let's say, specializing in cybersecurity, well, this is the domain that's going to introduce you into the world of cybersecurity. So we'll talk about the core foundation of security here, the CIA, right? The confidentiality, integrity, and availability. We'll talk about encryption. When you want to hide things, you can encrypt it, and then you will be given a key, and then you have to keep the key secure. So we'll talk about all that there, but also talk about cryptography, which is like that big idea of how people hide things online on the internet as well. So we'll talk about PKI, public key infrastructure. That's kind of a huge topic. Uh, any technological class, it will not be complete without, encryption and PKI and things like that, because this is what we use to secure the internet. Okay, but because this is all about networking security, well, as we go in and talk about these concepts, we'll talk about authentication. Absolutely, that comes in mind. So things like multi-factor authentication, single sign-on, like a remote authentication, Radius, LDAP, TACACS, SAML, the TACACS Plus. All of that stuff is going to be part of this section. And from there, we will dive into the network attacks and the type of a threat. So who is the enemy and what kind of attacks do they use to attack computer networks? So things like DOS attack, denial of a service, right? Distributed denial of service attack, so DDoS, right? VLAN hopping, MAC address filtering, and ARP spoofing, DNS poisoning, you name it, it's all going to be here, right? Evil twin, social engineering, malicious software like malware. All of that is going to be part of this network attacks and threats kind of a section of this domain. Then we'll finalize this domain by talking about how can you fix this? What are some of the ways that you can go in and hardening your network so that the attacker can just do whatever they want? And what are some of the best practices that are out there that we can put in place? So here we'll talk about disabling things you don't need. One of the biggest problem when it comes to cybersecurity is that we turn on too much. There's a lot of things running, a lot of ports, a lot of services running. So if you go in and you disable a service you don't need, well, that means the attacker cannot hack that because that thing is not available. Right? So we're going to talk about that, but also talk about, changing defaults. When it comes to hardening your system, it's about really turning off things, but also changing those default things, those like default passwords that belongs to users and administrator and all the other things that comes within your system. Then we'll talk about NAC, one of the technologies that I think is very much underutilized. This is the network access control, where we're going in and we're controlling who has access to what. So here we're going to put in technology such as port security in place, right? Port security, where if people are connecting to our environment, we decide, okay, what kind of a MAC address can we allow on this port? Okay, this is also known as 802.1x. I will dig a little bit deeper into this, but again, if you dive deeper into cybersecurity, you basically relearn a lot of the concepts that we're going to be talking about here. Then last but not least, the network troubleshooting. This is the last domain of the Network Plus exam. And this domain specifically weighs a lot when you compare this to the other domains. So you should expect a lot of questions from this particular domain, right? And it's all about troubleshooting. So what we're going to talk about here is the methodology of troubleshooting something, from identifying the problem, or you're trying to go in, you are identifying the issue. And the way you do that is by gathering the information, asking users some questions like, okay, what were you doing on this machine when the problem happened? And as you're going in and you basically identify the issue, you are going to try to duplicate the problem to see if you can kind of see what the users are telling you, if he's actually real. So from there, you're going to establish a theory of a probable cause. That's sort of like step 2 in this methodology. And the way you do that is by establishing and questioning the obvious, right? Consider multiple approaches to the problem from top to bottom, basically. This, you're going to go back to the OSI model, from the physical layer all the way to the application layer, trying to find out, okay, what kind of problem is this? And when in the real world, by the way, when it comes to troubleshooting networking issues, when you're talking to network engineers, they're going to tell you things like, oh, this is a layer 1 problem, or this is a layer 3 problem. Well, basically, what they're telling you is that, oh, this is a router's problem in the case of a layer three. If they say a layer one problem, you should expect this is like a physical security problem. So I probably should say physical security, but a physical problem. Maybe a wire got unplugged, things like that. So once we talk about the OSI model, it's going to be really important for you to understand that because it will help you in communicating with other people, other cybersecurity people in this field. But back to the methodology here. Once you kind of establish the probable cause, the next thing you do, you test the theory to kind of see if what you think is the problem, it's actually the problem. Then you will establish the plan of action. Then you're going to implement the solution. Then after that, you will verify the system functionality. Then last but not least, as a part of the methodology, you are going to documenting your findings. Absolutely. It's not done until it's documented. So very important. CompTIA will ask you a bunch of questions from this section. That's why I'm taking some time to sort of like explain what takes place here. But again, we have sections coming up later on where we're going to dig a little bit deeper into these. From there, we're going to dive into the cabling and physical interfaces issues. This is where you're going into troubleshooting a cables issues. Okay, you're like, okay, well, what could be the problem of like cable issues? Well, maybe the cable is not connected. Maybe they plug in it like the wrong cable, right? Because you will learn about different cables, things like twisted pair cable, STP, or unshielded twisted pair. You're going to learn about some of the cables that use a single mode, the cables that use multi-mode, right? You learn about different category of cables like Cat 5, Cat 6, Cat 7, Cat 8, fiber optic cables. All these cables, you learn about them. But what happens if you use like a different cables for a different device? Well, that's where some cabling issues comes in. What if you work in a data center and then maybe they plug it into a cable in a different locations where it shouldn't be? Well, that's where the cable issues comes in. So we will teach you how you should go in and troubleshoot these cables issues. And then once you troubleshoot them, how you should fix them. So we'll talk about all that here as well. Then that's going to take me to the network service and troubleshooting. Now, this section, it's all about troubleshooting common issues with network devices or some network services, if you will. So we'll talk about switching issues, like your switches issues, things like STP, that's spanning tree protocol. What happens if we have like a loop? A loop is when a switch doesn't know where to send the traffic to. So the traffic keeps kind of a looping around, not knowing where it's supposed to be going. What happens if there's some kind of VLAN issues? Well, we're going to sort of like troubleshoot that here. What about the router? Because when you talk about network services, you can't finish that without, discussing about the router. What kind of issues do we have with the router? Well, maybe we've implemented some routing protocol and then the routing protocol it's having some issues. Well, you will need to know how to troubleshoot that. Maybe the routing table, because a router will have like a little table of known other routers that the router talked to. Well, maybe that table we're having some issues. Maybe some attackers have injected some things on that table. We'll talk about all of that in this section as well. Then after that, we'll dive into troubleshooting performance issues. So again, these things are human-made. They will have issues. There could be some congestion issues, connection issues, bottleneck, maybe some bandwidth issues, packet loss. It could be some Wi-Fi interference issues, like wireless interference issues. So there could be all kinds of performance issues. We're going to troubleshoot them here as well. And I'll talk to you about this from like a little bit of a cybersecurity perspective because that's what I specialize in. For example, if your hardware have been using 50% of all the hardware capacity, then one day you wake up and the hardware it's up to 90%. Well, that's not normal. That increase in bandwidth is not normal. So part of us establishing a baseline, it's by really knowing how things are performing in our environment. So troubleshooting performance issues, it's really important, even from cybersecurity perspective as well. Now, after talking about all these issues that you can troubleshoot, the last thing, which I really like CompTIA for doing this, we're going to talk about solutions, right? We can't just keep talking about problems and problems and problems. We need solutions. That's what a company is going to hire you for. In fact, when I teach cybersecurity classes, I tell students all the time, you should not be going to management to be always telling them, we have these many attacks, right? No, you got to go to them, tell them the solutions. Like, okay, these are the amount of attacks that we're able to stop. and not just keep telling them we're under attack. These are the many things. No. Go to them with the solution. So in this section, network tools for troubleshooting, we're going to talk about some of the protocols and tools that you can use to troubleshoot all of these networking issues. So we got some software solutions, software tools, things like netcat, pinging things, NS lookup, TCP dump, digging into things, netstat, you name it. All those are software that we use when we're working with our network. So we'll talk about those. Then from there, we'll talk about also hardware tools. Oh yeah, what's some of the hardware tools that we use to be able to troubleshoot these issues, but also, bring solutions. Things like Wi-Fi analyzer for the Wi-Fi, right? Cable tester, so you can be able to test those spaghetti networks. So we'll talk about all those there as well. And then some of the basic kind of networking commands, right? In this section, we will go to Kali Linux, so you can do this live. You can get to see this. So some commands like show me the IP address, show me the routing address, and so on and so forth. So really looking forward to this section. Let's begin with the evolution of computer networking. So we can see that early days, we're talking about before you and I were alive, networks were around. They have the telegraph. We're talking about 1800s. They had the telephone network, calling people, been around for a very long time, where they can send voice communications over a distance, people calling each other. Then radio came around. Now we have a wireless transmission, right? Communication can transfer through the air now. Okay, and these technology really set the course for everything really that we're going to be talking about in this class. But we're not going to focus on this. But what I want to spend a little bit more time on speaking about is this right here. Come in 1960s and 70s. This is when they had just finished, I think, fighting the World War. Again, this is all from, reading books and things. It's not like I was alive. I'm sure most people who are listening to this, they probably were not alive either. But in the 1960s, they just finished fighting, World War II, and the U.S. government, right, the United States, the U.S. Department of Defense, kind of went to DARPA. DARPA is a research kind of agency that's within the U.S. government that deals with the kind of advanced research, meaning they research the most advanced things. So the U.S. government turned to DARPA and says to DARPA, hey, DARPA, we want to create a network that can survive a nuclear attacks. You see where I'm going with this. So they're going in there saying, even if there's like a nuke dropping right here, right now, we want to make sure this network can survive that. Guess what they came up with? Well, they sit around and they discuss about it, and they said, you know what? Let's go ahead and make this decentralized. Meaning, if we're going to need a network that can withstand a nuke, it has to be decentralized. So the very first version they came up with was known as ARPANET. ARPANET. So ARPANET, you can think of this as the Internet version 1. This was the official name for it. So they start doing research, and ARPANET was born in 69. And from there, they start connecting kind of computers to each other. So the first network connects two computers was in 1966. Then from this was all with these scientists, these researchers that were working on this. So they said, we have researchers in this state. We have another researcher in this state. Let's kind of, connect these networks so we can share resources. All right, at least that's, what the book says. That was the whole idea. Then from there, they start connecting universities. So colleges start connecting it to this network. And after universities start connecting to share resources like documents and things accelerated very quickly. There was an invention of what we normally call a packet switching, which was introduced to kind of help these computers that were connecting it to each other, so that as they're sharing this data, the data doesn't get sent into one packet, if you will. So it can be broken down into smaller pockets. We're going to talk about this in more depth. This is actually known as TCP, or the transmission control protocol, which was invented by this gentleman and Robert. Okay, so they invented that, and this helped as they were trying to get this ARPANET going. They said, you know what, we need a way of transmitting information on this ARPANET. This is superhighway that we created. We need some kind of a bus, right? Some kind of an airplane that can transfer things on this. And TCP was born on top of our IEP. This is the Internet Protocol. I will talk about all of these in the upcoming modules, but for now, just note that this is sort of the origin. They wanted to make sure they create a network that can withstand a nuclear attack, and they had to make that decentralized, right? It couldn't belong to anybody, any servers, any data centers. It had to belong to everybody. And that takes me to the rise of the local area network, right? The LANs. So this gentleman that's looking at here, he's still alive. Both of these guys are still alive. In 1980s, as they were going in the 60s and 70s, inventing a lot of the underlying technology that we use today, as DARPA and all these other researchers were going in and doing that, Robert, the gentleman that you're looking at here, invented something that would change networks as we know it. He invented what we call the local area network, a LAN. You're like, okay, what is a LAN? Well, a LAN, or a local area network, it's like a network that connects computers that are within the same kind of a location. It could be in an office, at school, at the business, at a home. It really don't matter. If you connect a few computers together, you are forming what we normally call a LAN, because you allow those computers to be able to share resources, to share files and things like that. Okay, so you will connect all of them to what we normally call a switch. I'll teach you what a switch is. Okay, so you bring your machines, you connect it to all of them. Maybe you add a printer to this. Okay, as this is like computer 1, computer 2, computer 3. Then you have a printer here. Well, if you could do something like this, this is what a LAN is, a local area network. Every networks, pretty much all the networks are local area networks, the ones that you have in your houses. And as people were going in and creating their own local area network, they were creating their little LAN in the offices, in the schools, in the businesses. We needed a way, like a standard protocol, meaning a rule that helps these computers to talk to each other, a practical way of having these machines talking to each other. And that's what really, the TCP, the transmission control protocol, and the Internet Protocol kind of helped us accomplish. And we will be coming back to that in more depth. But then it becomes 1990s. This gentleman that you're looking at here, he's still alive. He teaches at the MIT, the Massachusetts Institute of Technology. This is Tim. Tim invented the the www. So he invented the World Wide Web. If you ever visited a website, you know how you got to type in www. Well, thanks to this gentleman. He invented that. But that's not the only thing. He also invented what we normally call HTML, the hypertext markup language. And this is used to create websites. Every website you've seen on the internet uses HTML. He also invented HTTP. HTTP. And HTTP is the protocol that runs on top of a TCP. I'll be teaching you all this. I'm just giving you an overview right now. But when he invented all of these three technologies, these were the only thing that were missing. So in 1990, going to 91, he invented these things. Then the internet took off. Okay, so by that time, it was still a school connecting to each other, research facility connecting to each other, but regular people and houses and other people around the world, they were not connected to this thing. But when Tim invented those three things, everything changed. So in the 90s, we can see there was a lot of dial-up connections, devices coming online. Broadband, wireless was also invented just around that time. When I say wireless, I'm talking about the Wi-Fi that we use. And then companies and houses start getting online. Now, coming up in 2000s to basically present. So in the 2000s, everybody's connecting to the internet. Then in 2005, we see what we normally call cloud computing, which I have a section where we're going to talk about this in more depth. And this allowed people to rent hardware now, right? Like you don't have to own a computer. You can rent somebody else's computer's resources. We're going to talk about that. But also we saw a lot of these networking companies like the Verizons and all these, giants kind of laid the foundation, like laying the fiber optic cables and into the ground to make the connection super, super fast. We saw a lot of Wi-Fi. There's different standards of a Wi-Fi, which I will be talking about that. Right now we have Wi-Fi 6, which is like the newest one. But recently there's also a push towards 5G. But prior to that, we had 4G, 3G, and things like that. But this is also revolutionizing, if you will, the internet or the network, excuse me, the network as we know it. Now, what about today? What if you're getting into the network engineering type of work? Well, what should you kind of worry about? Again, I have a slide towards the end where we'll come back to this, but I just want to, mention it here. So networking today and the future looks like this. There's this technology that's known as a SDN or software defined networking. It's a way of automating. I'm going to sort of like simplify this, but automating networks. Okay, so if you're going in and try to set up like a bunch of computers or a bunch of things talking to each other, well, what if you can do that using code? What if you don't have to manually set up these hardware? What if you can just get the virtualized version of these hardware and then kind of configure them through code? They call this infrastructure as code, okay, which is part of that SDN. Then you have your IoT. IoT is becoming huge. So some of you are like, I want to become a security, like a network engineer. Maybe focus on the IoT technology. Maybe focus on the SDN. Actually, it's now maybe you will have to do that because this is the future of network engineering as well. IoT is Internet of Things. Internet of Things is making pretty much things that were normally not connected to the internet, connected to the internet. So basically, we're going in and attaching microwaves to the internet, attaching your doorbell to the internet, attaching things, your sofa, your thermostat. We're going and we're attaching these things to the internet. So in reality, we're creating a network of Internet of Things. And I had a mentor who usually called this Internet of Crap, which I really find it funny because, I mean, I really don't need my microwave to be smart, right? The job of my microwave is just to heat up my food and that's it. I don't need my refrigerator reminding me that the food is about to expire. But again, you can't argue with marketing, right? Anyway, then you got to focus on the cloud networks as well. A lot of companies have moved into the cloud. Again, I will teach you what cloud computing is, but a lot of companies have migrated into the cloud. So knowing how to create these networks inside of the cloud is going to be really crucial. Now, if you're a kid and maybe you're in high school, or maybe you know somebody who is in high school, you see this kid, he's brilliant and he have like a bright future ahead of him, and then he loves computers and he really likes, networks. Well, get him to get into quantum networking. Quantum computers are here and they're here now. Google, Microsoft, they both have announced quantum chips. And that's not stopping, just like AI. Everybody's using AI now. I mean, really depends on who you ask. I probably should say everybody. But AI-driven networks are also here. So focusing on quantum and AI-driven networks will be very important, as well as edge computing, especially for these self-driving cars, but also for the IoTs. Right? IoTs really uh, flourish on edge computing. And you don't know what that is, I understand. I will teach you all that. But I just want to kind of point these out at the beginning because these are going to be part of this exam. You're like, okay, Francois, I think I understand what you are talking about. But what is a network in the first place? Well, one thing I can tell you is that networks are everywhere. Absolutely. There are home. Right now, you're watching this course, maybe using your phone and maybe using your computer. That computer is connected to a Wi-Fi router. And maybe that's not the only thing that's connected to that. Yeah, right? Maybe you have your TV on it. Maybe you have your other computing devices connected to it at home. Okay, so that's a network. So basically, it's multiple devices communicating with each other. That's really what a network is. And you can have that network at home, maybe at the office, maybe in the city, depends on the kind of network that we set it up. I will be talking about, the types of networks in a minute here. Even in the space, right? If you talk to Elon Musk, because I think he has a company known as a Starlink that he's sending like satellite in the sky to form a network, right? Allowing people to connect to the internet, even when they're in the middle of the, Atlantic Ocean, right? In the middle of the ocean somewhere, but still get like a network signal. That's really, some type of a space type of a stuff. Anyway, at its core, a network allows multiple computing devices. It could be servers, computers, Internet of Things, mobile devices, to be able not only to communicate with each other, but be able to share files and be able to access things that are shared on that network, like printers or storage and things like that. Now, these devices that form a network is what we call nodes. Now, I'm start telling you things that's going to be on that exam and things that you need to remember as a part of your tech training. A node. When you say a node, it's as equivalent of saying what we normally call an endpoint. Okay, what does that mean? Endpoint, it's really another way of saying a desktop computer, a laptop computer, smartphone, IoT devices, servers. For these to be able to connect to each other, you need some kind of a transmission. So we connect these devices, these nodes, using a wire, something like Ethernet cable. We call these RJ45. RJ45, or a fiber optic cable. These are the ones that are like the backbone of the internet. They're extremely fast. I'll teach you both of these. Or maybe we are using wireless, Wi-Fi. Maybe you're using cellular. Maybe you're using satellite. Maybe you're using, Starlink with Elon Musk. But that's the transmission media, right? Then you have your networking devices. Again, I'm going to give you an overview. We will be talking about all of this in more depth. So for the network to be formed, you need networking devices, things like switches. A switch is a hardware that allows endpoint devices to talk to each other. So basically, it's something that looks like that. Then you connect all your computer to it. Now, some switch are wireless, where you connect it via your radio wave, your radio frequency. But if this is like a physical switch where you got to attach your RJ45, your Ethernet cable to them, it looks like this. You connect a bunch of your devices. I'll show you pictures of switches and things like that once we get to those sections. But you connect to your devices there like that, and then off you go. You form that LAN, local area network. Okay. You also need routers. Switches can help you create a LAN, and router can help you create what we normally call a WAN, wide area network, which I will be, teaching you that in more depth later on. But the question is, okay, you're connected to your local area network. You're connected to your home network, for example. What happens if you want to go outside of your network? Well, then you need a router. A router is that device, the hardware device that's going to help you get outside of your network. I will be coming back to all that. You need a firewalls. Networks are not secure. You need devices that can secure you on the network. And that's where a firewall comes in. You need an access point, especially if you're going to be allowing Wi-Fi. You need access points. So access point, it's a hardware device that allows you to set up a Wi-Fi. Then once you have all of these, you also need rules. And that's where the TCP IP comes in. You need a protocols. The protocols. These are the rules of the data, how these devices are going to exchange the data. How are they going to communicate with each other? We need structure. And then we get that structure from TCP. We'll talk about TCP IP in more depth and all the other things that comes with it as well. What type of a network can you actually set up? Well, I have a few of them here, and these are going to be all over that exam. But the beauty is I have a section where we're going to kind of come back to all of these in more depth. But anyway, the first one is local area network, a LAN. We talked about this one. This is the network that you'll find in a single buildings or like a school campus, right? Or some kind of a business. Let me just put it that way. Because when it comes to a school campus, you could also use a CAN, which hold on a minute, we'll be coming back to that in a minute. But single buildings like home or businesses might set up a LAN. It's usually private for that geographical area, that building. Okay. It's the speed when you connect the things to a local area network, it's pretty fast. You're using that gigabit because the cables that you use here are what we normally call a Cat5. The Cat is category. So it could be like Cat 6, Cat 7, Cat 8, and each one of these transfer things in gigabytes. Some of them are like 10 plus gigabytes per second. That's how fast these things are. Anyway, so that's a LAN. So a local area network is a network you will set up at a home or in just an area that's close to each other. Okay. Usually it's private. Then you have your WAN. This is your wide area network. Okay. So the question is, okay, what happens if you need something that's outside of your local area network? Then you need the help of a WAN. A WAN is a network that is a little bit like a regional, meaning let's say that a whole city is connected to some kind of a network. Well, a city is probably not a great example because a city will fall under this metropolitan network, the main. But let's say that you want a whole region, okay? You want a whole country to be connected to like a single network. You can create a WAN for your own country. Okay, you can actually do that. Companies such as Comcast, these network providers, they do have these kind of things where, as a business, we can rent our a private WAN where we said we are Walmart. Walmart is a company that is in the US, but is everywhere, right? We are a Walmart, and we don't want to use the internet. Therefore, we're going to have our own private WAN. We can go to a company who has set that stuff up and rent one if that's what we want. Okay. But think of a WAN as a network that is very wide, as the name implies here, a wide area network. The internet, literally, the internet is an example of a WAN. It's a wide area network that is global. But WANs, there's a different type of a WANs, right? But the internet is an example of that as well. Usually, it's not owned by anybody. For example, the internet is not owned by any country. If the US right now decides to shut down the internet from from America, other people still use the internet. That's the beauty of the internet. It's decentralized. It doesn't belong to any company or any country. The speed for this is usually in the megabytes, and recently we've been getting some gigabytes, especially for those who do gaming. They really want to get that gig as far as the speed on the wide area network. Then you have your WAN, MAN. This is a metropolitan area network. This is a network that that spans over a city. Just put it that way. I live in the city of Atlanta. Let's say the city of Atlanta, they have their own network where they connect all the city related things to that network. Well, that would be known as a MAN, Metropolitan Area Network. Okay. Sometimes this is used for, linking like government buildings. Like if we got multiple government buildings in the same city, we don't want that to be connected. We want that to be able to talk to each other. We can definitely do that. And the speed, depending on how this whole thing is set up, it's relatively fast. Then you have your CAN. Sometime the CAN, the campus area network, sometimes people really take this and add that into the MAN and as a part of the MAN because this also can span multiple buildings as well. But some people also take that and drop that in as a part of the LAN. It really sort of like depends. But what is this? This is a campus. It's very famous in institutions like universities. Like if you've been at university location, you know how they have like buildings, and these buildings are around it. Like they've taken a bigger chunk of a space, and they have buildings in multiple locations. Yes, you can go in and create like a local area network per a building. Like, oh, these computers in building A, let's connect them here, and then let's run a wire from this building to another building. And you can do it that way, or you can just set up a CAN. This is the campus area network. It's a network usually that spans in universities or corporations, depends on how big the company is. If it's multiple offices or multiple buildings that are close to each other, well, that's where a CAN comes in. And some of you, I can hear you already. You're like, hold on first. What about when I connect it to my Bluetooth? Well, what kind of a network is that? That's PAN. This is a personal area network. I should have here. Yeah, personal area network. Okay, this is where you're connecting like your Bluetooth headsets, your smartwatch. You're using things like NFC, near field communication, NFC. If you ever use like things like Apple Pay, Android Pay, that's all NFC technology, and it's all part of this personal area network. Very close to each other, very small range. Then you have your wireless LAN. This is not really specifically called out on the exam objective, but I put it here because this is Wi-Fi. This is a Wi-Fi, but it's a LAN. You set this up at the building, or the company that you work for. So it's going to be working as a part of your local area network, but the communication that's going through, it's not running through the wires as of the LAN. It's running through those radio frequencies, right? It's running through those signals as well. Another one we have, it's a SAN. Again, this is going to be on that example, but wireless LAN and the SAN, storage area network, I don't really want you to think of these as, kind of a types of networks, because it really varies. So with the SAN, storage area network, this is where we set it up part of our network, and then we say this part is going to take care of the storage. This is where we're going to store everything, right? So it's not always listed among the classics. When I say the classics, I'm talking about these 4, 5, right? LAN, WAN, MAN, CAN, and PAN. Okay, so these are the classics. It's not always listed there, but if we had set it up, let's say a local area network, we can also attach a storage network to that, where everything on that local area network can be accessing like a single storage area as well. And that takes me to topology. So basic network topology, again, we will be coming back to a lot of what I'm talking about here. I'm just setting the stage. I'm setting the stage so you can, get to know the expectation. So you're like, okay, Francois, I got it. Might probably need to set up like a LAN. I got that. But, well, what type? What kind of a topology are we talking about? What kind of design can I put in place? Well, we have a few of them. One, it's a bus topology. Again, I'll be coming back to this. This is when you have a single cable, right? And that cable is shared by all the nodes, all the computers on that cable. Something like what you're looking at here right now. This right here, it's a bus topology. But you have like a single backbone cable, meaning a wire, and you got computers connecting from it, like this. This is a bus topology. Now, this is a simple to set up because you just have a wire and the things are connected from that. Really easy to set up. But the problem with this is what happens if this wire gets cut off here? Yeah, so you lose connection on the devices that was on the other side. Okay, so keep that in mind. Another topology we have is the star topology. This is when all the devices are connected to a central switch. This is what I was mentioning when I say you can create a local area network, a LAN. Right? It's like a star topology, where you have a switch similar to what you're looking at here right now, that right there, right? this is a star topology. You have a switch, and then you're connecting your computers to the switch. That's a star topology. It's easier to manage. And if there's like a problem with this connection here, it's the problem of this computer. It's not a problem of anything else that's connected to it. Okay, so it's a little bit easier to manage. Also, when it comes to isolating those faults, those devices that's not working, it's easier. You just unplug it, you plug another one. It's not going to disrupt any other devices that's connected to that switch. Another one we have is a ring topology. This is when all the computers, all the nodes, form a closed loop. It's like a ring, right? If you're married, you know what a ring is. Something like this, right? So there's like a loop, like a circle, and computers are connected to that circle. And what happens is the data, it's kind of a going around into this ring. So historically, this was used as a part of what the nomenclature a token ring networks. So the data travel around this ring, and I really don't think there's a lot of networks, not that I even can think of, that really utilize this topology, this type of a topology nowadays. Okay. What I know, it's a mesh. A mesh topology is important. And the reason why this is important is for redundancy purposes. And I'll talk about that in a minute. But what is a mesh? A mesh topology is when multiple interconnection devices are kind of connected with each other. In another word, you have computers, and this computer is talking to that computer, but also is talking to this other machine, but also is talking to this other machine. What that means is if one of these wires gets cut off, it's okay, because it can still get signals from the other wires that's connected to it. So this is really good in military. Like a lot of the military networks are mesh topology type of networks. So it provides a high redundancy, but it's also expensive. And it can get confusing to manage as well, because you have a lot of things communicating with a lot of other things for redundancy purposes. But what you can do maybe a partial mesh. You don't have to do a full mesh, you can do partial, where we don't want this thing to talk to everybody else. Maybe let's have this thing talk to just two other machines, and that's about it. That's a partial mesh. You're like, okay, Francois, I think I got it. What happens if I want to use two of these? Well, that's when you get into the hybrid. Hybrid topology is a combination of the two or more of these network topologies. For example, the example that you're looking at here, this is a hybrid. It's a really good hybrid, because right here we have a bus topology. We also have a star. We have this star, but it's also running on that line for the bus topology as well. Now, what are some of the trends that I see? When I talk to these network engineers and some of the people that I have in my network, what do they see, or what is the industry pushing, and what's the future looks like? I have mentioned some of these already, so I won't spend too much time here, but a lot of things have been virtualized. Virtualization is when you take something that was usually physical, then you virtualize it. You use a software to be able to virtualize it. For example, you used to have to buy a router. Now we have a virtual router. You used to buy a switch. Now we have a virtual switch. Okay, so virtualization was escalated with the introduction of a cloud computing. And a cloud computing is just a bunch of computers that you can rent. It has nothing to do with the cloud. When somebody says a cloud computing, they're talking about there's some computers in some buildings somewhere, and you as a business or as an individual, you can rent that computer and pay the cloud provider some money, either monthly or yearly or maybe hourly in some cases. So there's a shift of the infrastructure into the cloud, because companies now, they don't want to be buying this hardware, configure this hardware, set it up. It takes a long time. It takes seconds to go to something like AWS, Amazon Web Services, and then get yourself an account, set it up, and then start running some routers and switches and things like that. Okay. So infrastructure are going from on-premises. This is where the company was hosting everything physically. So all this hardware we're talking about, they have that there physically, but they're moving into the cloud. But you also have some companies that are doing hybrid. Maybe some portion of their infrastructure is in the cloud. Maybe some other portion of their infrastructure is on-prem. Okay. Then you have your SD-WAN. We talked about this. This is the software-defined networking. So the software-defined networking, like I mentioned, is the idea of a centralizing control using code. Okay, we have this, some kind of a brain. I'll teach you all this, but some kind of a brain where we can set rules, and those rules gets pushed. Those rules could be for configuring a router. It could be for configuring a firewall. So I said a firewall, but a lot of these, it's really for, networking. But again, we're going to try to automate stuff. That's the idea behind SD-WANs. Okay, that's really huge. That's Cisco pushed this quite a lot. Then you have your IoT, Internet of Things, and Edge. Very important. There's a lot of devices coming online, billions of them, part of that Internet of Things. So knowing how to configure this Internet of Things network and keeping it secure as they're developing protocols and things for this type of a network, the IoT, because IoT, it's struggling with security right now, but IoT is here and is here to stay. I have a friend who works for Microsoft. He's a researcher. And then he's making over $250,000 a year. $250K a year researching IoT. So it's doable, absolutely. If you're a kid and you're watching this and you say, you know what, I want to focus on this, like I said earlier, focus on IoT and you will thank me later. Then you have edge computing. Edge computing, it's a technology that's coming, sort of like being added on top of a cloud computing. So when you see things like self-driving cars, these cars, as they're driving themselves on the road, they don't have time to go into the cloud to get an instruction. If another car in front of this self-driving car stopped, well, the self-driving cars needs to make a decision right there then. There is no time to go into the cloud and download an instruction and then take a break. So the edge computing is the idea of bringing in like some kind of a network capability or some kind of a processes at the edge. So for example, in a self-driving car, we will have all the decisions being made at the edge of that device, at the edge of that car in this case. So a bunch of these self-driving cars, as they're being driven, if they're in the same place, they're going to talk to each other. They're going to basically sharing intelligence and sharing data. Again, part of that edge, that's the network that they have, telling you like, hey, smart car that's behind me, they stopped in front of me. So you should sort of like start slowing down as well. Then you have your 5G and you have your Wi-Fi 6. Again, this is wireless. Really, really trying to increase the speed that we have within our phone. So you have that low latency connections and things like that. So maybe you want to become a technician that set up 5G infrastructure. That's all networks. And Network Plus will help you understand a lot of that. Then we have zero trust. So zero trust is really not a lot about networks, because I will talk about this, but this is more of a security that we should put in place once we have these sort of like networks in the cloud. Because the problem with having things in the cloud is, okay, who is accessing what, where they're accessing it from, what devices are they using. So zero trust comes in and help us with that continuous verification. Going in and keep asking those questions like, you're connecting to this network, got it. Where are you connecting from? What IP address are you using? Which MAC address are you connected to? Are you connected from the same location? How are you behaving, right? This is the philosophy of trust no one and always verify. So we will talk about that. We'll also talk about this secure access service gateway, or known as a SASE as well. Last but not least, I mentioned this AI networking. So you got to learn this artificial intelligence and networking. That's the future. That's the future, as well as quantum computing in networking as well. Welcome to this other section. Now, this is the OSI and the TCP/IP model section, where we're going to talk about both of these and talk about them in more depth. But before we dive in, I want to show you something. I'm going to bring up the exam objective. This is the Network Plus exam objective that I'm preparing you for. And I want to show you that the way the whole class is going to be based on the exam objective. So we're not going to be skipping around. We're going to follow this. We will talk about each one of these one by one. Obviously, I will make it a little bit easier for you to understand it because some of this information is all over the places, which is okay. But right now, I just want to show you that the section we're on is 1.1. And from there, we're going to get to 1.2. From there, we're going to get to 1.3. So I am following the exam objective. Well, I found out it's a little bit easier for you when we do it like this, because you want to make sure you're cross-checking this. You come in and you're saying, I understand what the physical layer does, check. I understand what a session layer is, check, right? Because the promise is if you know everything that is on this exam objective, you should be able to pass the exam. With that, let me get back to the slides here. So welcome back. Now, like I said, this is the OSI and the TCP/IP model section, where we're going to talk about the introduction of networking models. So here, we will learn about how two computers talk to each other. This is, I like to think, is the most important section in all networking, because when you understand TCP/IP and the OSI model, you understand networks, because this is the backbone of networks. I remember this one time I interviewed for a network engineering job, and I never got the job, but I still remember the interview process. They asked me a question about TCP/IP. They said, hey, describe the three-way handshake over TCP. And lucky me, I knew what that was. But again, we're not going to talk about that in this section. This is more just introducing you to the OSI. And you cannot talk about the OSI without talking about TCP, which is why I've condensed both of them here. So again, we'll start with the introduction of networking models, where they came from. Then we'll get into the OSI model overview. I'll talk about this in a little bit, depth. Then break it down, because this thing has 7 layers. Then we will break it down, each one of the layers, talk about it in more depth, so you can fully understand what's going on, because the OSI is designed to help us understand what networks are. And from there, we'll put this into a real world. Imagine you're delivering a mail, like mail delivery. Well, how does the OSI translate to that right there? So we'll take a look at what's going on there. Then after that, get into the TCP/IP model. Then talk about the difference between OSI and the TCP/IP, because OSI, it's more of a theory. I'll tell you that right now. OSI is more of a theory. We use this to explain what is going on between two computers. And TCP/IP, it's more of a practical. This is how you go in and you implement this. So OSI have 7 layers and TCP/IP have only 4 layers. Okay, remember that for your exam. Then we'll talk about encapsulation and de-encapsulation. So this is the process of how data moves from a layer 1 all the way to layer 7, and how data moves back up, again, from 7 all the way to 1. Okay, so that's known as encapsulation and de-encapsulation. This is how the data flow from a point A to point B. Then I'll finish this by talking about protocols that you could find on each one of these layers. I think that's important, even though we have a section where we're going to talk about protocols in more depth. So with that, let's get into it. Introduction to networking model. A network model is a structured set of rules. I want you to remember that. Structured set of rules that defines how computers or devices communicate on a network. Keyword here is structure. Another keyword is rules. When two computers are communicating with each other, well, they need to agree on into how they're going to communicate, how they're going to share this. And back in the 70s, when they were coming up with these OSI and these, TCP/IP and things, this was a big problem. I remember I was watching something that talked about this, and they said that in those days, this is when Microsoft was starting out and Apple was starting out with their, Apple company. And they were all using their own proprietary things. This is where IBM was IBM back in those days. I wasn't alive. So don't be like, were you alive back then? No, I just like history. So this is where IBM was doing what IBM does or did. I don't know what they're up to these days. But anyway, so they have their own proprietary kind of a protocols. Remember, rules of how their computers are going to be talking to each other. This was a problem because if you buy an IBM computer, that computer couldn't talk to Apple computer. So they said, you know what? We need a structure. We need a set of rules that every computer is going to be following. Why? For compatibility reasons and interoperability reasons, so that different vendors can design hardware and devices and create software that's going to obey these rules, that's going to follow these rules. So the two things that they came up with was the OSI model. And the OSI model was developed by International Organization for Standardization, IOS. Nobody remembers that. If this wasn't here, I'll probably won't remember what this is. But OSI is the Open System Interconnection, like I mentioned. And it does have 7 layers from what we normally call a physical layer all the way to the application layer. We'll talk about each one of these in more depth. But that's the OSI. So when they developed this, it was really good on how to explain things. So it was more like a blueprint theory that talks about how network communication takes place when two devices are talking to each other. What exactly happens from A to B? Then, like we said, the Department of Defense, DoD, said, you know what, we got to put this into practical. They came up with TCP and IP. So this is the Transmission Control Protocol and IP protocol, or IP, Internet Protocol. Usually they go together. This model was developed by the DoD as a way of putting OSI into practical. Let me just put it that way. Okay. And it only has about 4 layers. And it can map to the OSI. I will show you all that in a minute. But we still use it today. And I mean, I don't see any substitution to the TCP IP. I'm sure some people are working on it, but TCP IP works. It works well. And in fact, IP itself, the Internet Protocol, worked so well that they forgot to include the troubleshooting and they forgot to, to say maybe it's going to have issues in the future. And they end up designing other protocols that can help to troubleshoot this instead of messing with IP because it worked that well. So OSI model overview. Like I mentioned, OSI has about 7 layers from physical layer, which is layer 1, data link layer, layer 2, network layer, transport layer, session layer, presentation layer, and application layer. I wanted to say these one by one so you can kind of hear me saying them because you got to remember this for this exam. But one of the things that you can start asking yourself is, okay, well, I got the name of these, but how do I remember this? Where there's these mnemonics. I'm not even saying that word right, but this is some of the classic way of people remembering these. And one, it's all people seem to need data processing. This is where you start from the bottom, going to the top, meaning from application all the way to physical. Okay. Or you can start from the top to the bottom, where you said, please do not throw sausage pizza away. If you will, taking any network plus class, they're going to at least include this one. Right? They're just really that popular. This is going to help you remembering which one, as you see. P, that's physical. D, that's data link. N, that's network. T, that's transport. S, that's session. You got the idea. Okay, so all people seem to need data processing. And please, pretty please, in the voice of my daughter, please, pretty please, do not throw sausage pizza away. Okay. So, but what happens in each one of these layers? Well, a couple of things. first of all, when we're at the physical layer, there's a lot of things that, takes place here. There are hardware that are here at the physical layer. You're like, okay, well, what kind of hardware? Cables. Cables are hardware. Cables can be found at the physical link layer. Not physical layer. Okay. Other devices. Well, a hub. I haven't talked about what a hub is, but a hub, it's something that looks like a switch, but a hub is not smart. It's not intelligent. When you send something to a hub, it's going to broadcast it to everybody else. So you will find that at the physical layer, which is layer 1. So again, at the physical layer, it's really in the name. It's physical. This is where we're dealing with the electronic signals that's going through the wires, those RJ45 cables, those Cat5 cables, and things like that. And now that we're talking about this, I'm going to start showing you this so you can kind of get an idea of what these things are. Let me go back here. And let me show you what a hub is. Computer hub. There we go. Go back here. This is a hub. This is a hub. It looks just like a switch, but this is a hub. For example, this one has about 5 connections here. So what happens is, if you connect all the 5 computers to this thing, well, every time it receives something, it's going to broadcast that to everybody else. Every computer that's connected to this will receive a copy of that message, of that conversation. That's not good. Why? Because imagine if the attacker is connected here. Imagine if some bad guys is connected here. Now they also get a copy of our message. So this is a pretty good example here. There we go. A hub. When they receive a signal, it broadcasts that to everybody, as you can see it there. And another thing I want to show you is network cables. Let me say RJ45. Move a hub. So you can, we're going to take it slow, guys. Take a little bit slow. I know some of you are completely new to this stuff, so I'm going to take it a little bit slow here. This is the RJ45 cable. This is the Ethernet cable. And the reason why we call this RJ45 is because the pins, if you were to take this thing off and then count the pins there are 45 of them. That's why we call this RJ45. RJ stands for register jack. Maybe that's somebody's name. I don't know. But it's register jack 45. Okay. So this is a cable, and this is what you will see on the physical layer of the OSI model. So that's at the physical. When you connect the things at the physical, that's what we're dealing with. Wireless, like your Wi-Fi, it's also at the physical layer. And people will be like, oh, what if I'm connected to the Wi-Fi? Does that mean it's at the physical layer? Absolutely, it's at the physical layer. Okay. Then that takes me to layer number 2. That's the data link layer. On the data link layer, this is where we're dealing with the switch. We're dealing with the switch. You're like, okay, can I see an example of a switch? Yes, you can. Let's go back here. Let me bring up a switch. Let me go back to this one. Let me bring up those Cisco switch. A switch is a hardware. Looks like this. If you remember, we said a switch is used to create your local area network, your LAN. Okay. And this is a switch here. So what happens is, let me actually just pick one. There we go. What happens is you connect your computers to all of these. A lot of the switches have about 45 ports. A lot of the Cisco switches are, I should say, like 45 ports. I don't think this one does, but I'm sure this one does, and that one. Right? They're like business switches. I'm not talking about like your home, switches. Ports. TS. There we go. And you connect your computers here, computer 1, computer 2, computer 3. So this, everything within the switch is at the data link layer of the OSI model. Because now we're coming from the computer through the wire, right, at the physical link layer, to the wire, into the switch. So that's at the layer 2, data link. I hope you're not following what I'm writing, because I'm just writing stuff. is a data link layer. There you go, data link layer, right? At the layer 2 of the OSI model. But you also saw a few things on that slide, which I will be coming back to. But here they said you got MAC addresses. MAC is the media access control. The inside of a switch, if you were to log into the switch, you should be able to find what we normally call a MAC address. Okay, like, what the heck is a MAC address? MAC address, it's a number that is burned to every computer. Let me go ahead and bring this thing here. It's known as NIC card. NIC is a network interface card. It sounds like a name of someone, but it's a network interface card. And these are in every computer. The reason why this works at the switch is because once your computer is communicating with the switch, that's how a switch talks to the computer, is through this MAC address. That's how we identify the unique of the computer. When it receives something, that's how it knows this goes to computer A based on that MAC address. You know, what the heck is a MAC address? It's the unique number that is assigned to every network interface card. These are the network interface card, these right here. So there's a MAC address number that is burned into this, and that number is unique. It's 48-bit long, it's a hexadecimal. I will get into all that in a later section. But just know right now, MAC addresses are assigned to every one of the computers by the manufacturer, by the vendor. So Dell computer, well, Dell will give this unique number to a computer that they manufacture. Anyway, so the MAC address is what you will find at data link layer. And part of the reason is because switch uses that MAC address to be able to talk to the computers. Okay. And then, you know, about frames and packets and things like that, I'll get to that later. I'm going to just, if I say all of it, it's just going to be long just for this, you know, one section. But anyway, let's keep going. Then you have your network layer, layer 3. At the layer 3, the kind of hardware you have is routers. If you remember earlier, or if you remember, routers are hardware that we use to get outside of our network. Yeah, that's really what a router does. So these are routers. These are like home routers that, you know, a lot of us, you know, have some of these at home. But you want to get outside of your network. You want to go to www.google.com. Well, google.com, my friend, is not in your house, but is on the internet there somewhere. Guess who you're going to go to get you outside of your network? Their router. So you're going to go to Mr. Router and be like, hey, Mr. Router, I'm looking for google.com, but in my local area network, in my LAN, there we go. Those keywords are coming back. In my LAN, I cannot find google.com. Can you please go on the internet there somewhere and find google.com and bring him here to me? So the router is going to be like, got it, right? It's going to go out there, find Google, bring a Google, give Google to the switch, and the switch, using its intelligence, it's going to know, okay, this was requested by this particular computer. Okay, using that MAC address that I just finished talking about. Let's keep going. So what kind of things that you will find at the layer 3? IP addresses. So routers have IP addresses inside of them so that our computers can be able to talk to the router. But also when the router receives things from the internet, we know who to send it to. Well, we do that based on this number, this IP address. IP address can be changed. Okay, you're like, okay, what is an example of an IP address? So something like 10.1.1.0. That's an IP address. Specifically, this is an IP version 4 IP address. Okay, this gets assigned inside of the router. Why? So that our computer can reach out to this router and be like, hey, router, go on the internet to find something for me. But also, whenever that thing has been found on the internet, when it gets sent back, it will send it back to the router using this IP address as well. Okay, so that's the job of a router, and it happens to be on layer 3 of our OSI model. And that takes me to the transport layer, layer 4. Layer 4 is where you will find things like firewall. A firewall. Like, what the heck is a firewall? It's a hardware that is responsible for securing your network. Most of these hardware are found at the transport layer, okay, layer 4. But the two things that we have on layer 4 that I really want you to be aware of is TCP. That's the transmission control protocol. But we also have UDP. This is the user datagram protocol. Okay, if you remember when we were talking about TCP, we said TCP is like a bus. It takes the transport. All right, that's why it's on the transport layer. When I want to send something, to someone, I will give that to TCP. Hey, TCP, carry this on to this computer. And TCP is going to be like, yes. Not only am I going to carry this for you, but I will make sure I deliver it. That's the promise of a TCP. I'll come back to that. That's known as the three-way handshake. TCP, it's what we call it connection-oriented, meaning when it takes something, it will make sure it delivers it. So there's the guaranteed delivery. Now, when it comes to UDP, it's a completely different. UDP, again, is the user datagram protocol. I will be coming back to all of these guys. I'm just throwing a lot at you because I want to overwhelm you, which is exactly a good thing. When you are overwhelmed, that means you're learning something new. Some people disagree with me on that one. Anyway, UDP, user datagram protocol. So this one is different because there's no guaranteed delivery. When it still delivers the stuff, it's still at the transport here. But it doesn't really make sure that something have reached its final destination. So think of UDP as the, what's the unreliable package delivery in the US? I want to say UPS. I hope nobody works at the UPS listening to this. But UPS, right? When they deliver something, they're not even going to knock on the door. Like, they show up at your house, they drop it, they leave. Again, I will be coming back to that delivering of a mail analogy to make sure you understand all of this in a physical setting. Okay, so never mind the segmentation and these other things, I will be coming back to all of this. But what else can I mention here? There's a lot to mention at the transport layer. But for now, that should be enough. Then you have your session layer. This is layer number 5. Session layer and the presentation layer, these gets a little bit harder to talk about them or maybe explain them because what they do, it's mostly done by the application. Okay, I want you to stay with me. That's why the TCP/IP model has about 4 layers. Again, I'm getting ahead of myself here. But back to the session. Session layer establishes and maintains and terminates sessions. Basically, if you and I are communicating over Zoom, for example, well, session layer is the layer that's going to establish that session for us. Okay, in theory, by the way. But what does that work is the Zoom application. That's really why I established that connection between me and you as we're communicating over Zoom. Then you have your presentation layer. Presentation layer deals with the encryption and compression and formatting of the data. Compression and decompression, encrypting the data, de-encrypting the data, that kind of stuff. Okay, this is the presentation layer. As the information is coming down this layer, when it gets to encryption, for example, let's say it's going to some user, and that user is using some kind of application to access the data. Well, when it gets to presentation, the presentation is going to get it from the computer language, meaning get it from these ones and zeros into something that a human can look at and read and understand. What does that? Presentation layer does that for us. That's layer number 6. Again, all of that is done by the application. And that takes me to layer number 7, the application layer. This is user interfaces. So right here on the application, this is where the user is interacting with some kind of application. And depending on that application, depending on whatever the application that is, they're able to create things, they're able to send things, they're able to access things, read things, you name it. It's all done at the application. So this is the application facing layer. For example, if you go on the web right now and start using something like Gmail, Gmail is for email. You're like, yeah, it's for email. So Gmail is the application. As a user, I'm right there using Gmail, which is good. So I go into Gmail, I compose the email. I draft my email, I write out my email, then I hit send. Well, as soon as I hit send, the Gmail application, it's not only going to, it's going to compress my email into something that now a computer can understand, getting it out of the English language, sort of speaking, and translate that into binary, ones and zeros. And from there, the session will be established, then it's going to get into the transport all the way until it gets to the other end, to the wire, and then goes to the other end, and so on and so forth. Okay, I'm hoping you're still with me. I took a little bit longer to this, so that's because it's going to be in all over that exam. Like I said, this is the quickest way to remember this. A lot of people seem to need data processing, and please do not throw sausage pizza away. And these are the 7 layers of the OSI model. We just finished talking about each one of these, from the application all the way to the physical. We talked about what they do, their functions. But also one thing that I want to mention here is that there are some protocols and devices that you will find in each one of these layers. It's important for you to know what those are, because not only they're going to be on that exam, but even when you're troubleshooting networks, you got to know what these are. Some people are going to tell you, hey, we're having a layer 3 problem, where you should know right there then they're talking about maybe a router, or they're talking about some IP addresses is not functioning. Okay, well, what can you do in that case? Maybe you want to use something like ICMP. It's another protocol. ICMP to be able to troubleshoot the IP. Okay, maybe they're having some routing protocol issue, something like OSPF or BGP, which we're going to talk about all of these in more depth once we get there. But again, protocols and devices can be found in different layers of the OSI model. And the rest of this class, we're going to talk about each one of these in more depth. And that takes me to this real world analogy of delivering a mail. Okay, so think of this from this perspective of delivering a mail. Let's say you want to deliver a mail to a friend. Well, what do? Well, first thing you do, you write the letter. That's the application layer. You're going in, you get a pen and a paper, and you start writing things down. You say, hey, dear Francois, I enjoy your class. Hopefully you will do that. So this is a user communicating. That's at the application layer. And like I said before, a lot of what happens practically, a lot of what happens with the layer 5 and 6, it's usually done at the application. So this user is going to go in and maybe write the letter and write it in a way where nobody can just read it. Maybe the user is obfuscating the letter. Let's just put it that way. Again, I'm giving this as an example, not exactly what could or should happen. But again, they develop the letter right here. That's step 1. Second is packaging the letter. Okay, that's what happens with the within layer 4, specifically with the TCP and UDP. Now we're deciding, okay, how this letter it's going to get there. What are we going to use? Do we want to use something that's reliable, like TCP, or do we want to just use UDP, where they just deliver it? We don't care if they're gonna knock on the door. We don't care if somebody sign the letter or sign before they receive the letter. So we're going in and we're packaging this and we're making those decisions. We're deciding which one we're going to use between these two. And then that's layer 4. And then we go to layer 3. This is when you're choosing the delivery route. Okay, then you decide, okay, how this letter is going to be delivered. That's at the network layer. Okay. Within the network layer, like I said, this is where we have routers, and a router have routing protocols. Things like OSPF, open shortest path first. We're going to talk about this. Things like RIP. This is not really rest in peace, but they really should call this rest in peace. It's been around for a long time and nobody really uses this anymore, but it's RIP. It's another routing protocol. BGP, EIGRP, you name it. I will be teaching you all these, but this is where you choose. You say, you know what? Let me use OSPF because it's going to deliver this faster. So you choose the delivery route, right? In the case of mail delivery. Then here on the data link layer, this is when you add you address the envelope. Okay, so right here, for example, within choosing the delivery, you can think of that as a UPS or FedEx. This is all US, guys. So if you're outside of the US, you're like, what is UPS? This is the United Postal Service. I think that's what that stands for. But anyway, you go in and you're choosing the delivery route, okay, how that's going to be delivered as well. And then on the data link layer, you added the address. So maybe you went there, you got to the building where at the UPS store. Now you're adding the address of the person who's going to be getting this mail that you're sending. So that's the MAC address. Remember, this is unique. And remember, an address of someone is unique. If you're going to send something to me right now, I have to give you my address. Then you specifically said he lives in the US, in the state known as Georgia, in the city that's known as I was going to say Alabama, but Atlanta, and in the county that's known as this county, and so on and so forth. So that's very unique, and that's how that later is going to reach me. Because if you just say, hey, let's just send it to Francois, who happens to live in the US. How many Francois are in the US? Probably a lot. Well, let's send it to Francois, who lives in the US, but also lives in Atlanta. Well, maybe there's a couple of Francois in Atlanta. I don't know. But anyway, you got the idea. So the data link layer, this is where we're addressing the envelope. Then the mail track delivers the data. This is the physical layer. Depending on what we use, if it's a UPS, FedEx, and we decide if it's going to be reliable or not, well, the mail track delivers the data. If we went in and we say it's going to be reliable, well, this delivery, this conversation, in the case of computers, if this is a TCP is going to be like, hey, I want to send this to this particular person. Are you there? Or this particular computer, are you there? That's the TCP, and we call this a three-way handshake, which I will be teaching you that as well. Now, let me ask you this, because you just learned about the OSI matter, and I believe I took my very sweet time to explain all this. Maybe some of you are getting bored already. But let me ask you this. Which layer do you think is most critical for securing data? I'm going to pause. Which layer do you think is very critical for securing data? And I'm not going to give you the answer. And a part of the reason is we live in the age of AI right now. Critical thinking will become very important. Remembering and memorizing a bunch of stuff, it's not going to help you. You're going to have to know how to think critically. And this is what I'm trying to do with my classes, is to inject a few questions along the way. And I want you to pause. I want you to pause, read over the question, and start thinking about what the question is asking you so that you can kind of jog your memory into everything you just learned. Try to sort of like think critically through it. So which layer do you think is most critical for securing data? And that takes me to TCP/IP model. Okay. Again, this was developed by the US Department of Defense for implementation of the OSI. Just put it that way. And it's still used today in the networks. So it's really used everywhere, including in the internet. So this one consists of 4 layers. So what happened is they took the 7 layers, then they condensed them together and they renamed some of these things. For example, they have this thing known as the network interface, or what they call a link layer. Well, this is the physical layer and the data link layer of the OSI model. Okay, I'll bring a diagram here for us to kind of look at this, a little bit better. Okay, but then the network layer, they call that the internet layer. The transport layer didn't change. It's the same. This is the layer 4. And the application layer, it's called the application layer in the OSI model, in the TCP/IP. But this application layer is that layer 7, layer 6, and layer 5. So they condensed all of them together and they said, let's just call this. So let's go to Google here so I can show you the quickly difference between these. So let me bring up TCP/IP. Okay. So TCP/IP, again, you got 4 layers, but let's compare that to the OSI. It's better that way. OSI versus TCP/IP. And let me find a really good picture. This is looking good. Let's bring this up here. There we go. Let's talk about this from here. So you can kind of see this from the photo here. Now, as you can see, we have the application layer, right? And the application layer has that presentation session and so on and so forth. Now, in the TCP, they said, you know what, let's just call that the application. Because like you saw it when I was explaining presentation and session, it's really hard to differentiate like what's going on in each one of these. And all the books you're going to read, they're just going to keep telling you session layer, establish the session. You're like, what does that exactly mean? Presentation layer is going to encrypt things and decrypt things and compress things and decompress things. All the books you're going to read, they're going to tell you all that, that same exactly stuff. But everything is done by the application. So to make it easier in the TCP/IP, they just said, you know what? The application layer is handling the data. Okay. Then you have your the lower layer, if you will. That sometimes they call that what you see here. But here we have the transport layer, layer 4. And the transport layer, it's the transport layer. They didn't change the name. Then the internet layer is the layer 3 here, and that's the network layer. Okay, the network layer here, layer 3. Then you have your data link layer as well as your physical layer, and those are known as the network interface or the link layer when it comes to the TCP/IP. The reason is it's a little bit also iffy to differentiate between a data link layer and a physical layer. Yes, at the physical layer, we're dealing with the physical hardware. With when I say physical, I'm talking about the wires. We're dealing with the bits and bytes. Okay, but at the data link, yes, we're dealing with the frames and we're dealing with the switches. Now I'm talking about this because that's what I'm going to talk about next. But we're dealing with the switch. But some of the things that you can find at the data link layer, you can also find them on the physical, and we'll talk about those. So what the TCP/IP layer did is said, you know what? Let's just go ahead and name this link layer. Okay. Then there's some other things that you're looking at here. You said, oh, here they say data, segments, packets, frames, bits. What does that mean? We are going to talk about this next. Encapsulation and the data flow. Well, you've seen what they call data, segments, datagram, packets, frames, bits and bytes. You wonder, what are these things? Well, these are what we normally call PDUs. PDU stands for Protocol Data Unit, but I'm getting ahead of myself. Well, what is encapsulation in the first place? Well, encapsulation is the process of adding headers and sometimes trailers, meaning removing things, to a data. Keyword here is data, as it moves through the OSI or the TCP layer. In other words, as the data is going from the application layer all the way to the physical layer, there's things that gets added to it and things that gets removed to it. So for example, We're here at the application layer and we're trying to send an email. Okay. So on the application layer, we're dealing with the data. Absolutely. We're dealing with the email that we're composing. We're using something like SMTP. This is the simple mail transfer protocol. That's the protocol that we're dealing with here. Okay. Well, once we finish composing the email, we hit the send. That email goes into the transport. Okay, guess what? Transport is going to add something to that data. So once the data gets into the transport, we don't call it data anymore. We will call that a segment or a datagram, depending if it's using TCP or UDP at the transport layer. So once the email gets to the transport, getting ready to be transported to wherever it's going, well, if we were using a TCP for the transport, well, that data, it's going to be the name, the official name is going to be converted to segment because now we've added a TCP stuff to it. Okay, I'm hoping that makes sense. And if we're adding a UDP to it, well, that data name, it's going to change to datagram. So ideally, we simply call, everything here is either data or packets. That's literally the official name of the data as the data is moving from point A to point B. It's going through this OSI model. But for the sake of this exam, it's important for you to know these PDUs, these protocol data units, the official names as well as the data as they go from point A to point B or move down to this OSI model. But anyway, once it gets to the network layer, we are adding IP addresses, right? This is at the network. So the data now is changed to a packet. You literally like, oh, there's 30 packets, right? That means there's 30 data passing by here. Then when the data gets into a switch from the router, gets into a switch or at the data link, now we call this a frame. Frames. Okay, that's the PDUs. Okay, a frame. So this is the Wi-Fi data or the Ethernet data is going to a switch. And then when the data gets into a physical wire, it's the ones and zeros now. This is the bits and bytes, the binary. Okay, the signal, the electronic signal that goes from, through the wire as going from point A to point B. So these are the PDUs, the protocol data unit. Basically, it's a fancy way of saying a data based on what it is on the OSI. You will see a lot of these technical people coming to you and telling you, we're having a layer 3 problem. All these packets are not working. Well, when they say packet, sometimes they're talking about the data. Probably not sometimes, all the time they're talking about the data. If they're saying, hey, we're having frame issues, well, they're talking about switches. And they're basically calling the data that is at the switch. And looking at this process, if you will, at the from a top to bottom, it looks like what you're looking at here. Okay, at the application layer, we have the data. This is when the user sends a request using some kind of an application, such as like a web browser. Maybe they're opening like a website using a web browser. So the application is going to generate the raw data. All right, this is the data that we're talking about that's going to be sent over the network. Then it gets to the transport. Again, the name changes to segments or datagram, depends on who you ask. And this is going to be on that exam. They're going to ask you, when the data gets to layer 4 of the OSI model, the transport layer, what is the name for it? What is the PDU for it? You need to know it's segment if it's using TCP, or it's datagram if it's using UDP. Okay. And then you have your packets at layer 3 of the OSI model. Then you have your frames at the layer 2. And then you have your bits and bytes. There's other things here that we're going to talk about later on. Things like it's going to chunk this into small chunks. It's going to add a sequence number. All that stuff will be discussed once we dig a little bit deeper into this. But for now, just know this is the encapsulation process from top to bottom. And then that takes them to de-encapsulation process. So what happens once the data it reaches its destination? Well, that's when the things that were added, it gets removed. So if I go back to here very quickly, when it gets to the other destination, it's going to come through the physical, right? It's going to come through, let me go back here, through the physical. So it's going to come as bits and bytes, as ones and zeros. So it's going to get through the wire, from the wire to the switch. Okay, so the switch is going to remove the frames, then the packets, they're going to remove the IP address, then the segments on until it gets to a user. So in the case of the email, everything the computer added, the encapsulation processor will have to de-encapsulate, meaning they're going to remove all the PDUs that were added to it so that I can be able to read it as a user. Because if they keep it into the computing language, I won't be able to understand it. And that's the de-encapsulation process. Okay, we're going in at the destination, the data moves up the OSI model. Okay, so the physical layer converts the signal back to the data. The data link layer extracts the frames and then it verifies the integrity, makes sure the data is original. The network layer removes the IP header and then forwards the data to the correction process, meaning layer 4 of the OSI model. At the transport layer, it resembles the data, right? The segments, if this was chunked down into small pieces, it's going to assemble it and then ship it out to the application layer. As you can see, everything we're talking about right now, it's practical. And this is the TCP IP, the 4 process. You can go going from a physical all the way to the network, all the way to the transport and to the application. And one of the things that I wanted to do was to introduce you to what we normally call the protocols. I sort of mentioned this already, but these are the key networking protocols that you will kind of keep an eye on at each layer of the OSI model or the TCP IP. And if you remember, a network protocol is rules, right? This one defines rules and the standards, how the communication is going to take place between the two devices that are communicating. So each protocol operates at a specific layer of the OSI model. So it really depends on the kind of a protocol that we're dealing with. Remember, because these are the rules, so they kind of ensure the interoperability so that the systems that are completely different to each other are able to talk to each other, able to share conversation. And we sort of touched up on this. We will come back to each one of these in more depth, but I just want to introduce them here. But you got things at the application, things like HTTP for the web traffic. You got things like FTP for file transfer protocol. That's what that stands for. Traffic, sharing file online. You got things like SMTP for email. Okay, it really depends on what you're doing. It's designed for all kinds of things. You got POP3, you got IMAP. Both of these are for email. You got things like SSH, secure shell to remote into computers. You got Telnet. Nobody uses Telnet anymore because it's not secure. You got things like DNS for domain name systems. All of that's taking place at the application layer. Depending on the application that you're dealing with, you got web traffic, email traffic, file transferring traffic, and so on and so forth. Okay. Then at the presentation layer, you got things like SSH/TLS, which is also at the application layer. Like I mentioned, these 3 are the same. But at the session layer, you got things like PPP, point-to-point protocol, SIP, the session initiation protocol, or if we were dealing with the video conversation where we're establishing a session, okay? And then at the transport layer, you got things like TCP and UDP, and each one of these, oh my God, it got over 65,000 and I think 355, I believe, something like that. There's over 65,000 protocols that can run on top of a TCP. There's over 65,000 protocols that can also run on top of UDP. I will be coming back to each one of them because all of these protocols, they also have a port number. For example, when we talk about HTTP, well, that's port 80. And when you're a network engineer, maybe you're doing some cybersecurity related things. You go into a firewall, you're trying to block HTTP. Well, how are you going to do that? You might do that with port 80. Well, there's over 65,000 of these port numbers that can be assigned and that can be used on each one of these. Because remember, computers, they don't speak, this HTTP. They don't understand none of that. They only understand one or a zero. We call this a binary. So everything computers do have to be converted into a number, one or a zero, which is where these port numbers comes in as well. So if binary, you didn't learn a little bit of binary, it's okay for you to look it up a little bit of it, but it's not really necessary. Okay. And then at the network layer, we also have a protocol there. Things like IP addresses, ICMP, ARP, RIP, right? OSPF, BGP, NAT. All these are the protocols that you find at the network layer. Then on the data link layer, you got things like Wi-Fi, 802.1q for trunking, right? You got different Wi-Fi standards here. Ethernet, it's here. ARP, right? Same thing that you find on layer 3 is here. The point-to-point protocol that I mentioned, frame relay, all that stuff is on the layer 2 of the OSI model. Okay. Then on the physical layer, you got Bluetooth there. Wi-Fi is there. Ethernet cables and fiber optics. It's all there. These are like the common language, if you will. They define the rules. If you're going in, you're creating like a physical hardware and you want that physical hardware to communicate with other hardware, you want to make sure you're following the rules of Wi-Fi, the rules of Bluetooth, if you need that thing to be communicating with other things at the physical layer. Okay, so this is a little bit of a high overview. I'm simplifying this, but we will come back to it. And I always tell students that, look, when we're talking about networking protocols, these are the things that you need to remember for the sake of the exam, and then go ahead and forget about them once you're done taking the exam. Because in the real world, guys, we Google this stuff. And one more thing as I wrap up this section, I want to make sure that you got everything you need to pass the exam. So on the platform, the Cyber Pros, here we go, I'm going to write it here, training platform, training.com. All right. So the cyberprostraining.com, we have questions. These are a quiz. Each section have a quiz. These are just about 5 questions for me to assess if you understand everything you just learned. So again, I highly encourage you to take the quiz so you can check your understanding. If your goal is to pass this exam, this is the only way. You got to take the quiz because towards the end of all the lessons, you are going to take these CompTIA quizzes, these mock questions, and I want you to pass them. And the way you pass them is by taking these quizzes. So please do take the quiz, quiz yourself after every section so that you know that you're understanding the material or if you should be asking questions. Now, because I really want you to pass the exam, we're going to do some lab activity throughout this course. If we talk about some topic and there's a way for us to lab that topic, we're going to do exactly just that. So for now, let's go ahead and do the OSI packet analysis using Wireshark. So go ahead and bring on your VMware workstation. And once you have that up, go ahead and turn on your Kali Linux. So click on that and then click on power on. Okay. And you can also power on your Meta. It's not really necessary, but power on Kali. We need Kali for this to work. I'm going to go ahead and close this library so I have a little bit more room here. I'm going to click on the X to close that. And I'll sign in with Kali and the password of Kali again. And now we're going to capture traffic using Wireshark. So we can see that the OSI model in action in real world, or at least that TCP IP. So what I will do here, I'll click on the Kali logo. Then in the search here, I will type in Wireshark. Okay, or just type in wire and the Wireshark is going to come up. So click on Wireshark. And I'll go ahead and maximize that so I'll be able to see the whole full screen. And the Wireshark on the welcome page is going to show me some interface. One of them is ETH0. There's the any, there's the loopback. There's a few other things that we don't care about. Right now, all I care about is the ETH0, and that's the one that has some network connectivity taking place. So I'll go ahead and double click on ETH0 right there, double click on it to start capturing traffic. And right now it's capturing things, but because I'm not doing anything on this computer, there's nothing taking place here. But if I were to bring up my my terminal here, so I'm going to click on the terminal. Let me go ahead and just exit out of here so you can put this on the side. You can see it. There we go. This is my terminal here right now. Yes, Kali, the one that I brought up by clicking on that. I can here ping that IP address. When I say IP address, I'm talking about the meta. So if you have a meta up, go ahead and ping meta. So type in ping space 10.0.0.14. Your IP address is going to look a little bit different. It's not going to be mine. So again, you can figure out what your IP address is by going to the meta computer and then sign in, then type in ifconfig. Okay, let me actually do that. I can sign in with MSF admin. Type in the password of MSF admin again. Now, once I'm here, I'm going to type in ifconfig, press enter. And here I can see my IP address right there with inet is 10.0.0.14. Go back to my Kali here and I'm pinging this IP. Basically, I'm asking, hey, are you up? Now I'm running Wireshark in the background so that I can be able to capture this conversation. I'm going to go ahead and press enter. And as you can see, it's pinging right now, right? It's pinging. It went in and pinged 4 times. And here's the beauty. When you're pinging something, you're asking, hey, buddy, are you up? And you are sending in what we normally call the ICMP packets. That's what you're sending in, okay? So let me go ahead and do another thing so I can be able to capture more data, and then we're going to get back to this, show you what's going on here. Let's say I go to a web. I open the Firefox browser. Okay, I'm going to go ahead and open that up. As you can see, it started capturing a lot of things as Firefox is coming up. Okay, let me just put this on the side so you get to see it there as well. So let me go to google.com. Basically, everything that I'm doing right now is being captured. Wireshark, it's capturing all of it. So let me say I go to HTTP websites. Let me just search for HTTP website. And let me just go to one. Let me see if I can find this one. Maybe this one right here. I think they try to secure it now. Let me remove the S. Let me see if I can access it without the security. Yep, yes, I can. Right now, I'm accessing it without security with HTTP. I press in one of these. The lock right there still indicating I'm not, it's not with HTTPS. There we go. I'm browsing through it. Basically, I'm creating traffic so Wireshark can be able to capture those things as well. So I go back to Google here. Okay, and Wireshark is capturing all of that. Let me go ahead and close the browser and get back to Wireshark. I'm going to go ahead and click on this red triangle the icon to stop capturing. Okay, there we go. And now we have Wireshark. Let's zoom in. I'm going to click on view and click on zoom or point to zoom, then pick zoom in. You can also do Control++. Let me do it the hard way. Zoom, there we go. Zoom. Zoom. Zoom some more. Okay. Now it's a little bit too big, but I just want to show you a few things. Maybe I can zoom out once. There we go. Maybe zoom out twice. There we go. Better. Better. I'm sure you can still see this. Okay. So this is Wireshark. This is absolutely Wireshark doing what Wireshark does. And here, let's say that I want to see the OSI, because that's what we're talking about. Let's say that I want to see the the OSI from the application all the way to everything else. I can go into this filter here and search for HTTP traffic. Just type in HTTP. I'm going to press enter. It's going to go in and bring me the HTTP traffic, just the HTTP traffic. And right now, I can see a few things. First of all, let me bring in my annotation tool here. I can see the timing. When did this took place? I can see the source. Where did it come from? It came from my computer, 10.0.0.17, which is my Kali's IP address. It went to this destination, whatever the IP address that right there, okay? And there was that, the OSCSP to check to make sure if this is the right traffic, that kind of stuff. But the request that was taking place, started from right here, that right there, get. Okay, so my computer right there, source, my computer, reached out to this computer right here, and then asking to get some data, get some HTTP traffic. That's what was taking place here. If I zoom in a little bit, let me go ahead and just put that up based on just that traffic. So you can see that OSI taking place. Not really OSI, more of a TCP IP. I can see that we have a frame. If you remember, we said a frame is what is taking place at, let me bring the TCP IP traffic. Let me go ahead and just put that up and bring it here so that you can be able to see this TCP IP model, so that you can see everything that we learned actually applies here. There we go. Let me go ahead and bring it back, the OSI model versus a TCP one. The same one that we used as an example. I'm going to just leave it here so you can kind of be able to see this a little bit better. Let me go ahead and zoom in. I think that's, zoomed in enough. Anyway, this is right here. This is Wireshark traffic, right? This is Wireshark traffic. And we can see that as I expand the first one here, this says frame bits. If I bring back this picture quickly here, you can see that this is where bits are taking place. That's at the physical layer. So on this traffic of my computer reaching out, asking for an HTTP traffic, we can see that there was, at the wire, if I expand that, you can see what was taking place. It's Ethernet, things that we learned, and we can see the time, when things happen, all that good stuff. And then it takes us to layer 2. Let me go ahead and bring my annotation here as I bring on this, and keep this right here so you get to see this. Let me just talk about all of these at the same time without moving. There we go. It's a little bit easier for you to comprehend. So here, this is the physical link layer, right there. That's right here. That's that network interface layer when it comes to TCP IP. We're dealing with the bytes and bits and wire, right there. And then we have that layer 2 of the OSI model, right there, the Ethernet. And this is where we're dealing with frames. And we can see we have some source MAC address. If you remember, we talked about MAC addresses. And we have some destination MAC addresses because this is like a VMware machine. It's showing me some VMware stuff. And if I expand the Ethernet here, we can see that this is the destination MAC address right there. You can also see the source MAC address right there. So when the conversation was coming back to me, these were the MAC addresses that were used. Then you can see the layer 3, the internet protocol, the network layer. And right here, we have source IP. Remember, the IP addresses are here. So we have the source IP addresses. We also have the destination IP address right there. And then we can see some layer 4 stuff. There are the transmission control protocol type of a stuff. You can see the source port. In this case, is dynamic, which means it was automatically generated, right? Whatever that number is right there. Then we can see the destination port. In our case, it's port 80. Port 80, why? Because this is the HTTP traffic. If this could have been like a different type of a traffic, the destination port will be different. And then we can also see in Wireshark, we can see some sequence number and some acknowledgement, taking place because we were using TCP, the transmission control protocol. That's what was taking place, which uses the three-way handshake. I haven't talked about that, but I will in this Network Plus class. And then we can see some source number, like I mentioned. We can also see the destination number. We can also see we were using TCP in this case. There's also a window wing number as a part of the sequence number. We're not going to get into that right now. But then we can see that layer 7 or 5, 6, and 7. In this case, we're using HTTP. And with the HTTP, we can see we're getting things. We went in and we say, hey, get me this web page. That's really what was taking place here. And we can see what we were getting. So if I lower that down here, actually, let me bring up back the OSI model so you can see that everything that we talked about. So we can see the data in the application right here. In the application, that's where we are right now, the hypertext transfer protocol. We got the data, and the data, it's here. Let me move this away. This is the data. Wireshark kind of give us that view, so we are able to see what we were getting in hex. That's what you're looking at here, hex. But also we can see the actual content that we were getting, right, in this case. So bring this back up here. We can see that the transport, we're using segment because that's the transmission control protocol. Okay, that's the data here at the transport. We're using TCP. And at the network layer packets, we're dealing with the source IP is that, and this is my colleague's IP address. And the destination IP is that. That's the computer, the other computer on the other side of the world that I'm communicating with. And on the frames, like I said, frames, this is at the switch. We're dealing with the MAC addresses. So we can see this is the MAC for the destination. That's the MAC for the source as well. I just want to make sure you see that the way Wireshark display things, it's based on the OSI model as well as the TCP IP model. And a lot of people in cybersecurity, we use Wireshark for forensic purposes, for trying to understand what's going on between two machines, and so on and so forth. So let me bring this down and get back to this packet here, this data. I can right click on that and then go to follow and just say, hey, I want to follow the HTTP stream. Actually, let me just go with the TCP since that's what we learned. So I can click on TCP stream. And now this allows me to see additional things, additional data. I can see the GET, meaning HTTP reaching out and be like, hey, get me this web page. And because HTTP is not encrypted, meaning it's not secure, I'm able to see all the conversation. I'm able to see the server. This was Nginx right there. I'm able to see the content. I'm able to see the time when this was taking place, right? This was a success, the information that I got back, right? And so on and so forth. Okay. Let me close this and go back here. And here I can also search for that ping. If I go here and type in ICMP, which is the protocol that ping uses, I will teach you all this. I can see when I ping the meta, the net meta computer, it came from me, which is my IP address is that. It went to this guy with .14, and I can see that. The protocol was used is this, and this was just a request. I'm like, hey, can we talk? Then I receive a reply. A reply came back from this guy with the .14 to me. Okay. Basically, I reached the, hey, can we talk? A reply says, yeah, we can talk, which is really how ping works. So with the ping, it's a little bit different because we don't get to the application layer. So if I bring this back on here, it only utilizes the very first about 3 or 4 layers. because we really didn't get to the application, because right here we're dealing with the IP addresses. We're basically just asking, hey, buddy, are you up? So we still have the frames, right? The data, the physical layer. We also have the Ethernet, the MAC addresses taking place. And in this case, this is the MAC address of my Kali computer and the MAC address of the Meta, the NetMeta computer. And then we have the IP address taking place, .17 as the source, also with the .14 as the destination, and that's about it. That's about it. We don't get to layer 4. We don't get to the TCP, the UDP, none of that. Again, that's why I was running ping so I can show you the different type of a traffic. This is ICMP. This is a pinging. When you're pinging something, you're basically just saying, hey, are you up? That doesn't need internet connection. This is all at the LAN, a local area network. As these were communicating, both of these computers are connected on the same LAN. Like, how do you know that? If I bring this back up here and click on the Kali, actually, now I can't see it because these are running, but both of these are connected to, let me see if I go to virtual private, if you'll be able to see it. Yeah, both of them are connected here, right, on this network, 10.0.0.0. Okay, this virtual switch. Therefore, they're connected on the same local area network, virtually anyway. Okay, so this is what Wireshark. We're gonna do some other interesting things on Wireshark as a part of this class. I just want to show you this from a TCP/IP perspective and the OSI model perspective, how we use this in the real world. Welcome back. In this section, we are going to talk about networking appliances and networking applications. So we will start with the overview, talk about what are some of the core networking appliances that are out there. Obviously, the people who understand some of these, they're going to start thinking about routers and switches, maybe some firewalls. Maybe we can put an intrusion detection system and intrusion prevention system on the network. And that will be correct. So we'll talk about all of these networking appliances, what they are, how they work, kind of dig a little bit deeper into these devices. Now, when you talk about networking appliances, it used to be all hardware. So be like, okay, well, we need to buy a router, then we need to connect that to a switch, then that switch needs to be connected to some computers and that, that kind of stuff. But over the years, these have changed. Now we have virtual networking appliances using a virtualization. So I will introduce that here as well, but we will have some sections later on where we will dig a little bit deeper into each one of these topics in more depth. So we'll talk about the hardware networking appliances and talk about the virtualized network appliances. And then kind of talk about the key networking appliances that are out there that you must have when you're setting up, a network. Then we will add a little bit more into this and talk about proxy servers and load balancers, what they are, what they do, and why you should care about this when you're setting up a network. We'll talk about storage, specifically the network attached storage and the storage area network, or what people call SAN. You will learn what's the difference between the two, which one is better over the other, and which one would you use depending on the kind of use cases that you're dealing with. You cannot talk about networking without talking about wireless, because nowadays people are connected via what? Via their cell phones, laptops. So we'll talk about networking, wireless networking appliances, including access points and access point controllers and all kinds of stuff that's, Wi-Fi related. We'll talk about those there. Then we'll finish this by talking about networking applications. What are some of the applications that we use when we're dealing with the network? When, for example, when you're dealing with the router, what are the applications that comes in mind, right? So talk about that in this section as well. Like I said, this is going to be more of like an introduction, as we will spend a lot of time in other domains of this class talking about these things in more depth. For example, with the firewall, and intrusion detection, intrusion prevention systems. Once we talk about cybersecurity, the security, the network security section, we will come back to this and add more content to it. But right here, it's more of an introduction to these things so that you have them in the back of your mind as we go on and talk about the rest of the content. Let's go. Let's start this conversation with the overview of networking appliance. So what is this? Well, a network appliance is a specialized hardware. It could also be a software. So if you're thinking about routers, you'll be right on the money. If you're thinking about switches, you'll be right. If you're thinking about, let's say, access points for your Wi-Fi, you will be right on the money. So there's a tons of different appliances, meaning, hardware that we use to our networks. So what do they do? Well, all these hardware and software in some cases, especially nowadays, there's a lot of software-based networking appliances. We'll talk about that. Basically, all I'm saying is all your routers, your switches, your access points, they all can be software-based now. Right? They can all be software-based now. But what are they all designed to do? Well, they're designed to manage the network, control the traffic, and in some cases, it depends on how we're doing this, we might do some security. For example, when it comes to a firewall, we can do what we normally call ACL, which I will be coming back to that. ACL, access control list. We can configure this inside of a router so that the router can control access, can be able to allow things or block things based on the rule, this particular rule known as ACL, access control list. So there are some security that we can do there. In the switch, there's some security that we can do there as well. But a network appliance on top of the security is designed to optimize the network traffic as well. So basically, as two machines are communicating with each other using the OSI model, a network appliance is the facilitator. It's supposed to do the specialized thing that is designed to do as these two things or these two devices are communicating. So they ensure efficiency data flow between those those devices that are communicating on the network. Like I mentioned, it could be a physical hardware. It could also be a virtual software. If it's running on what we normally call a hypervisor, you're like, what the heck is a hypervisor? Well, if you set up the lab setup that we did, you've worked with a hypervisor. So the VMware workstation that you were able to download and set up, that's a hypervisor. Basically, it's a software that is designed to allow you to virtualize other things like operating systems and things like that. In this case, networking appliances. So for example, let's say you want to run a router, but in this case, you don't have money to buy a physical hardware. It could be expensive. Then you don't know how to connect these hardware. So what you can do, well, set up a hypervisor and then spin up a bunch of virtual routers. Okay, so VMware have a few products. Workstation is not the only one. It has a few products, and one that does this at the enterprise level, it's known as ESXi. Okay, so some people call this a vSphere. This is the product that is a hypervisor that we can use in an enterprise environment to be able to set up virtual networks, be able to set up these software-based networking appliances. So this was taken by the cloud. If you never heard about the cloud, we will talk about this in the very next section. But the cloud came in and said, why just virtualized these appliances? Why can't we take that to the next level? And that's exactly what they did back in 2005, starting with Amazon AWS or Amazon Web Services. I'm getting ahead of myself. So physical appliances. Well, it's a dedicated hardware, absolutely. So as we're going in and try to buy a network appliance, we can buy, dedicated hardware. Of course, we can go to Cisco and be like, hey, Cisco, give us a switch. Hey, Cisco, we want a hardware. We want a router. We want a firewall. So it could be a physical appliance, but when you buy these, one, it takes time for them to ship that to you. Second, not only they do that, you are going to need technicians to connect all those things to the wire. So it's expensive. It requires time. and work and obviously a physical space, but it does provide better performance. Absolutely. When you set up anything physical, really, it could also even be your access point when you want Wi-Fi. So, and there's an option for you to connect like a wire to your computer. You should always go with the wire for better performance. Okay. So this is really good for the people or the company that still have what we normally call on-premise network, on-premises network. On-prem, it's when the company still have like a physical building and they need physical appliances. There are companies that are like that. A lot of companies have migrated into the cloud, but we do still have company that have on-prem networks as well. But like I said, a bunch of companies are going virtual now, especially migrating things into the cloud. So a virtual network appliance is a software based that runs on top of a hypervisor. Now, like I said, we can be using ESXi, or in our case, for just lab purposes, we have a VMware workstation. Okay, that's what we have. But we could also be going into the cloud. So this is really good, easy to scale because we don't have to wait for the shipment. We don't have to wait for the technician to connect to the hardware and all that stuff. It's all in the cloud. We can just spin it up and off we go. If I were to show you this, we're going to talk about the cloud in the next section, but let me go here and show you this quickly. If I go to AWS Marketplace, this is the Amazon Web Services. In 2005, Amazon started this whole cloud movement. I will talk about that in the next section. And everybody else followed them basically after that. Anyway, so they have this marketplace. So imagine if I need a router. So I can just go here, just search for a router. It could also be like a Cisco router. But let me just type in router. And here's a few things. pfSense, this is a free, and this is a firewall, but pfSense have some routing capability, VPNs and things like that. So, and for the most part, it's free, but I doubt if this is hosted on AWS, it's free. But besides, yeah, it's definitely not free. You pay 12 cents per hour. But we scroll down, you have this one. This is a very common too. But you also got Cisco, right? We should have Juniper here. We should have there's this one, OPN Sense too. Juniper, there we go. So basically you can come right here and just pick one of these, right? If you just want to deploy this and just set it up. Just view the purchase options in this case, and then off you go. You didn't have to wait for Juniper to send you this hardware. You didn't have to wait it. So that's the beauty of these virtualized appliances that we are talking about in this case. I keep talking about networking appliances, but what are some of the key network appliances that comes in mind? Well, the first one is a router. You can't really think about a network without thinking about a router. A router is that hardware that's literally on layer 3 of the OSI model, specifically for routing traffic. It deals with IP addresses just to be able to route traffic. So what does a router do? Well, a router allows you to get outside of your network. In other words, in your home network, maybe you have a LAN, a local area network. On your LAN, you have your computers here. You also might have your access point here. You have your TV, your phones, all of these things connected to your home area network. What happens when you are looking for something that's not part of your local area network? What if you are looking for Google? And in your local area network, you don't have anybody named Google. You don't have anybody called Google. So guess what your computers are going to do? They're going to reach out to the router. The router is what has what we normally call a default gateway. Default gateway. It's a default. It's that thing that everybody reaches out to when they want to go to the internet. So a router connects different networks together. So a router helps us create what we normally call a WAN, a wide area network. Okay, without a router, we will not have a WAN. And then you have a switch. It's another hardware that comes in mind. This one allows you to connect devices within the same network. Okay, so specifically on your LAN. So when you have a switch and then you connect a few things to the switch, I'm talking about computers or printers and things like that on the switch, you are forming what we normally call a LAN, a local area network, and the switch is the hardware that allows you to do that. Then you can just have a network without some security. A firewall is a networking appliance that is known to be mean. Very mean. Every time we start thinking about securing your network, a firewall comes in mind, and for a good reason. Firewall are very mean devices that filter traffic. They basically keep an eye on the traffic and then allow or deny access based on how that firewall is configured. So we can configure what we normally call firewall rules, which are basically same way of saying ACL, access control list, the same ones that you configure in the router. But firewall rules are specifically designed to just look at the traffic that's coming and then be like, are you allowed? If you're not allowed, drop it, right? It's going to stop it or allow it based on the rules that we set it up. But it is on the network. Specifically, it's at the edge of the network, meaning everything that's coming in after passing through the router, it comes to the firewall. It has to hit the firewall so the firewall can judge that traffic and be like, are you a good traffic? Are you a bad traffic? Are you supposed to be here? So we have a different type of firewalls, and we will talk about all those in later sections. Another appliance that's very, very important on your network is what we normally call an intrusion detection system. Keyword here is detection. Then we also have an intrusion prevention system, a keyword prevention. Both of these are designed to monitor your traffic. Basically, keep an eye on what is happening on your network. They work, to an extent, they work same way as a firewall. I don't want to think like that. I don't want you to think like they're the same. But one of them, it's just going to detect things. An IDS, specifically designed to just detect stuff. So basically, this is an appliance. It could be hardware or software. Snort is one. Snort. You can maybe look it up. Suricata is another one. Suricata, right? It's another one that we can set it up, and then it's going to keep watching our traffic. So the biggest difference here is one detects, another one prevents. So IDS is going to keep an eye on what's happening on the network and then send us an alert. Alert. Tell us, hey, you asked me to let you know if I see something bad. Here is an alert. Here is a log. I just want to let you know I just saw something passing by me and that thing is not good. That's what an IDS will do. Now, an IPS, on the other hand, is going to take steps. It's going to try to prevent this particular thing from happening. So an IPS, it does everything an IDS does with more, with the prevention and capability. Another tool we have, it's a load balancer. Load balancer does what it sounds like. It distributes the network traffic to ensure optimal performance. Optimal performance. And we have different types of load balancer. You have a network load balancer. You have an application load balancer. We will talk about both, those in more depth in the upcoming sections. You have your proxy server. This is a hardware or a software that acts as an intermediary. Basically, it's a hardware that's between a traffic, that's between two things communicating, right? Between two devices talking to each other. And there's a lot of reasons why a proxy is good, right? One, it can cache things, and then second, it can provide some security because it's between the two things communicating. So we can train the proxy server to look at certain things. Like, hey, Mr. Proxy, if you see this thing, do not allow it. But basically, a proxy server, it's a hardware software that does a request on the behalf of somebody else. So, for example, user A trying to get to the internet, but before they get to the internet, they go to the proxies first. The proxies is like, hey, Mr. User A, what are you looking for? Well, I'm looking for Google on the internet. Well, okay, stay here. I'm gonna go on the Google and then find Google. Then I'll bring Google and then give it Google back to you. Right. So it goes out there. It makes a request on the behalf of the user. That's what a proxy server does. Another network appliance we have, it's a NAS. This is the network attached storage, but you also have a SAN, storage area network. Both of these are used for storage purposes. If you're an enterprise company, you might want to go with the storage area network because it's better. It uses a fiber channel, it uses a TCP. Basically, you can connect this storage. The SAN can be on a different location. That's the beauty. But the NAS it's attached. So NAS is a network attached storage. It's usually attached to your local area network. Then you have your wireless access points. So wireless access points are like switches. I really want to take that back, but they're literally like switches, but they give you Wi-Fi signals. They give you those radio frequencies. They allow you to connect to your computers, your printers, your smartphones, right? Your laptops on the wireless. Okay, one of the vendor that's really, really good when it comes to Wi-Fi, it's known as Obakuki. So let me go here and show you these guys. They have this product that's known as a Unify. I'll be coming back to this in a later section here. This vendor, these guys right here. So they're pretty good. A lot of people are using them now, specifically like companies, small businesses, even some big businesses are using them now. But some of their Wi-Fi's are some of the best Wi-Fi I mean on the market right now. Again, I'm a little bit biased because I used to own these. I don't have them anymore. But it does have this Unify operating system, Unify OS, basically everything in your environment kind of hooked up to just one brain and off you go. So if you want to set up like your home wireless, um your surveillance cameras and all kinds of stuff, they have everything that you need, right? Unify, pretty good vendor for Wi-Fi as well. And that takes me to the router and the switches. So let's talk about these a little bit more. We won't spend too much time on this. So a router's job is to move data between the different networks. I think I've mentioned, I've made that clear. If you want to go outside of your network, you need to reach out to the router. Router has what we normally call a default gateway. For example, if I were to bring on my computer right now, let me go ahead and show you this. If I bring on my CMD, my command prompt, okay? And here's my command prompt, CMD. Let me see if I can zoom in into this right here. There we go. If I type in ipconfig, this is a Windows computer, so you don't type in ifconfig, you type in ipconfig. If I press enter right now and go to the Wi-Fi, because I'm connected to this laptop that I'm using via Wi-Fi, I can see the default gateway. The default gateway, which is this number right here, we haven't talked about IP address, but we will. But this number right here is my default gateway. In another word, this is my router's IP address. So my computer's IP address is this right here that you're looking at, IPv4 right there. So that's what is assigned to this computer that I'm sitting on. And this right here is the default gateway, which basically tells me that every time my every time my computer here, this laptop that I'm sitting on wants to communicate it to the internet, it reaches out to this guy, to this IP address. And then it's going to be like, hey, I'm looking for Google. Can you please go on the internet somewhere and find Google? You can't see it right now, but I will show you my router. It's literally next to me as I'm talking this right now. But I just want to show you where you will see that or where you'll find that in your computer. But that's a router. So it's going to analyze incoming packets and determines the best destination. And it's going to calculate that based on the route using what we normally call routing table. Again, there's a lot to unpack here, but I'm not going to talk about all of it here right now. I'm still giving you the overview. We will come back to things like routing tables and routing protocols and things like that. But basically, when a router is reaching out to the internet for you, it's going to do that. It will do its very best to get there as fast as it can. And the way it does that is through calculating the best path forward, meaning if I hop, it's known as router hopping. If I hop to this router and this router and this router, I will get to Google quicker. If Google happens to be in California, my router is gonna calculate to be like, okay, if I go to the router from Texas and another router in Atlanta, another router in California, I'll get to Google very quickly. So it does that based on a routing table, because that routing table, it's like just like a little database that have all other router that my router knows that my router can basically communicate with. Remember, without routers, there's no internet. The router is basically what creates the WAN, and WAN is the wide area network, and the internet itself, it's part of a WAN. It's one example of a WAN network, the internet. So router connects a bunch of LANs. Router connects a bunch of a local area network together to form what we normally call a WAN, or a wide area network. So router operates on a layer 3 of the ASI model. We discussed that in the previous videos. And you need to note that it's going to route traffic based on the IP addresses. That's why I showed you that command prompt so I can show you the IP address. So the way it calculates where to go, how you should go, it's going to use routing protocols, obviously, but it does need to know the IP address of who it's sending it the information to. So it provides WAN connectivity, like I mentioned. It does that using DSL, fiber optic cables, MPLS, and some other stuff. We will talk about all of those. It does support NAT. This is the network address translation, and its little cousin PAT. PAT is the port address translation. These two are some of the best technology inside of a router. And these two are the reasons why IP, I haven't talked about IP, but I just want to mention that here. IP version 4 have been in a business for this long, okay? Because with the network address translation, we're able to translate IP addresses from what we normally call a private IP address to public IP addresses, and vice versa. Then when you bring in the port, well, we don't even need to do one-on-one IP swiping or an IP address mapping. We can easily just swipe that with the port number. I'm probably confusing you right now. That's okay, because I haven't teach you a lot of this, but I will. Once we get to the IP addresses, we will be coming back to these and make sense of this. Okay. Now, inside of a router, like I mentioned, we can do a little bit of ACL. There's a little bit of a security that can be added to the router, including ACL. This is an access control list. Right? Think of that as like the firewall rule, where we can tell the router, allow this IP, block this IP, allow this other IP, block this other IP. So routers does that based on IP addresses. Keep that in mind. Because remember, it's on a layer 3. And guess what happens on layer 3? IP. It's the networking layer, okay? There's some VPN, this is virtual private network services that can be taking place in the router, depends on how we've configured the router. What about the switches? Because it sounds like a router does a lot of amazing stuff, and it does. What about on the switch? Well, a switch connects devices within the same local area network, and it's going to forward traffic, what we normally call frames. It's going to forward these frames based on the MAC addresses. MAC address is the media access control, like I mentioned before. This is the media access control. Every computer must have one. This is how the switch knows who to send the message to, who the message belongs to. So think about it this way. Imagine in your home network, you have TV, computers, phones, and few other things. So imagine you are using your phone to connect it to the internet. Using, let's say in this case, a switch. Let's just say you're using like an access control switch, like a Wi-Fi switch. Just stay with me. Well, as you're using your phone to get to the internet, well, how does the packet, when the traffic comes back, how does it know it should go to your particular phone? How does it know it doesn't go to my phone, although we have all these phones connected to that same exactly network? Oh, well, it does that based on the MAC address, the media access control address. This is unique to every hardware, and it gets used by routers and access points in order to forward frames, forward packets, forward data to that particular hardware. So a switch does have what we normally call a CAM table. chem table that keeps track of all these MAC addresses. Again, I'll dig a little bit deeper into that in later sections. It operates on layer 2, remember that for your exam. And there are some smart switches, or what we normally call the layer 3 switches, that also does some routing type of a stuff, right? Depend on what the company wants to do. Instead of writing separate devices, they can just buy a switch that does both some routing and some switches. We usually call those smart switches or layer 3 switches. Inside of a switch, we can do a little bit of security. I probably should say a little bit because there's a lot of security that we can do on the switch. The first one is VLAN segmentation. Segmentation is one of the best security that you can do. This is where you go into the switch. For example, think about this as a switch. And then you virtually, that's why this is called virtual local area network. That's what VLAN stands for, virtual local area network. So you can have like a physical switch like this and then virtually separate these LANs, these ports. Then you can say, okay, these 4 ports belongs to manager, like management, people who does management at the company. And then you can say these other ports belongs to the sales team. Okay, and then you can assign VLAN number to each one of these. That's that segmentation, the separation, where you go in and you're saying, okay, this right here for management is going to be VLAN 10. Then you can say, okay, these other 4 ports for sales, they're going to be VLAN 20. Okay, so when you do that, it's pretty good because now you have segmentation, you have separation. In other words, if people in management get attacked, if their computer gets attacked, not everybody that are connected to this switch will get affected, right? It's only going to stay with these 4 ports here that happens to be part of the same VLAN. Or I'm hoping that makes sense, but that's some of the security. And if you don't have your Security Plus, if you register into Security Plus, that's where we talk more about this in depth. So you can do the segmentation physically, maybe by buying a physical switch and then physically separate those switch, or it could be logical, like I said. So where you are virtualizing this. We can also do port security. This is also known as 802.1x. Now we'll come back to this. 802.1x is the standard that a switch uses for port security. Like, what the heck is port security? Well, port security is when you go into the port, a particular port of this switch, and then you tell the port, hey, Mr. Port, you're only allowed to learn 1 MAC address. Or you can only do like 5 MAC address and that's it. You're like, okay, well, why would you want to do that? Well, for security reasons. One of the attacker can do on the switch is what we normally call table MAC flooding. Okay, it's when they can go into the port and then flood the CAM table, that little database that have all the MAC addresses. They can flood it with the bogus MAC addresses and be like, hey, forget everything you know. From now on, you're going to learn these new MAC addresses. Well, if we've configured port security, that's not going to happen. Right? That port security is going to kick in and be like, hold on a minute. I can only allow 1 MAC address. I can only learn about 5 MAC addresses, and that's it. That's all I'm going to allow. Okay. In the switch, you can also do quality of service. This also can be pretty good for security, where we are prioritizing traffic. That's what QoS does. We'll talk about QoS in more depth. But we're going into we're prioritizing traffic. We're saying, hey, this is a web traffic, or this is a video traffic. It's a voice over IP. It's somebody communicating over the phone. Therefore, let's give more bandwidth to this voice over IP traffic. Okay, that's known as a QoS, quality of service. We'll come back to that. Nothing that can happen is PoE. PoE is power over Ethernet. This is really good if we want to charge the devices, to charge the things that are connected to our switch. In other words, we want the port to provide power, and this is good for voice over IP phones. So, for example, if we have like phones, those business phone lines that we have at the company, this is what we can do. We can buy a switch that's gonna give them power. As soon as you connect that cable to it, it's going to give it a power. We, at the company I used to work for, this is what we used to have. We had a switches from, what was the company? Now I'm running, but we had a switch that allowed us to assign power over Ethernet PoE on the phones that were connected to our environment. Moving on to the firewall and intrusion detection systems, intrusion prevention systems. So I talked about a lot of these already, but let me sort of like summarize a few things here for you. A firewall is that gatekeeper. This is the hardware that we're going to find at the edge of our network. And the number one reason or number one role of a firewall is to control the traffic. See how the traffic, keep an eye on how the traffic is flowing throughout the network, and then enforce those security rules that we created. So for the most part, the firewall is deployed at the perimeter, meaning at the beginning of the network. And the firewall is going to keep watching the traffic that's coming in and that's going out. Firewalls have a very easy decision to make. They keep things really simple. It's either you're allowed or you're denied. Simple as that. They might even drop the conversation, and when they drop the conversation, they are going to notify the sender, basically wherever the traffic came from. If the firewall drops the traffic, it's going to let the sender know, hey, I dropped your traffic, just so you know. But allow, that means the traffic can come through. Deny, that means the traffic is denied. And when the firewall denies the traffic, it's not going to notify anybody. It's more like a deny. That's it. Moving on. And then obviously we're going to get some logging from the firewall. Now, here's the thing about firewalls. They have what we normally call implicit deny. Implicit deny. This is why I told you that firewalls are very mean appliances. And the reason is by default, a firewall, it's going to block everything. There is no I'm allowing this. There's no I'm dropping this. It just all deny. By default, the firewall is just gonna deny everybody. But over time, or once we configure the firewall, we can let the firewall ease up a little bit and be like, hey, Mr. Firewall, let's go ahead and allow these IP addresses. Let's go ahead and allow these port numbers. Let's go ahead and allow these protocol numbers. And the firewall is just going to start doing that based on the rules that we set it up. Those firewalls rules, also known as access control list. Once you configure those inside of a firewall. So there are different types of firewalls. Some of them are packet filtering. They're going to just filter the traffic based on the packets as they're coming in and going out. We have some next generations firewalls. There's all kinds of firewalls on layer 4. Some firewalls are on layer 7, like application aware type of a firewalls, and so on and so forth. Then you have your IDS, intrusion and detection prevention systems. Like I said, the biggest the difference between IDS and IPS is that one is going to detect, another one is going to monitor. The thing about IPS, though, it's inline. It's inline with the traffic so that it can take action automatically. Now, IDS, it doesn't have to be inline. It can be a tap, and then this is a part of that deployment. In another word, it could be like a port mirroring, meaning we have a switch like this, and then we basically connect the IDS here, IDS on the switch. So as the traffic is going and leaving the switch, well, the switch can send a copy to the IDS. It's not in line, right? We just get a copy using this port. We can just get a copy. It's known as a port mirroring, meaning send me everything you see, Mr. Switch, through this particular port. Okay, so that's the IDS. And the reason, again, is to alert if it does seize any malicious activity, and it's passive. And some of these are layer 7. Some of them are layer 7 type of IDS. Now, IPS, on the other hand, is inline. And in another word, we have a switch like this. IPS is going to be inline through the traffic. It's not going to be on the side. It's going to be inline, meaning as the traffic is coming through the switch, it has to go through the IPS. Okay. And the beauty, it's going to actively prevent and block activities or malicious activity in this case. So in a sense, this is an active, and it could be layer 7. We have some that works on layer 4, that kind of stuff. Now, some people are like, okay, well, how do they do that? How are they able to watch, or how are they able to stop the traffic? Well, hold that thought. We'll be coming back to all that in a later section. But think of IDS as the security camera. It's going to keep watching and do nothing other than letting you know. And then think of IPS as the security guard. Not only is it going to watch, but it's going to take some steps to stop the intruder immediately. Load balancers and proxy servers. Where are they? Well, a load balancer is going to evenly, that's the keyword, evenly distribute incoming and outgoing network or application traffic across multiple servers. This is really important for you to know. The job of a load balancer is to distribute the load, meaning as the traffic is coming in, imagine if you have a couple of servers. We have server 1, server 2, server 3, server 4. Well, load balancer can be sitting right here. And as users are connecting to our network, well, they go through the load balancer. Then the load balancer is going to distribute the traffic based on different things. It could do that based on how health these servers are kind of functioning. So it'd be like, okay, server 1 is not too busy, so this traffic should go to server 1. Well, server 2, it's running a little bit low. This traffic should go to server 2. So this is really good for what? For redundancy and failover for availability purposes. In other words, imagine if you're a Google. You're a google.com and you get 1 billion searches every day. Right? 1 billion people search on Google. There's like 1 billion searches every day on Google. Now, do you think Google only has one server housing the google.com web page? And the answer is no. Google has thousands, if not millions, really, thousands of servers that are serving this. And the idea is that so as these billions of people are searching using Google, Google is load balancing between all those thousands of servers so that not a single server can be able to handle all those requests. That's the beauty, or that's the idea behind a load balancer, right? Is to keep an eye on everything that's coming in and then distribute the traffic evenly across multiple servers. So load balancers can be on layer 4 of the OSI model. That's the transport layer. And then it could also be the layer 7. That's the application layer. And when you got application-based load balancer, that means they're distributing the load between applications. And when you got layer 4 load balancer, that means they're working at the TCP and IP TCP level, right? TCP and UDP level. Okay. But if it's an application-based, it could be offloading SSL. SSL is this secure socket layer. We'll talk about this in more depth. But maybe we're doing some kind of a web-related things, and we want this to kick in. Okay. Now, I don't only have here, it's proxy servers. Let me go ahead and clear the screen here. There we go. Clear. Another hardware we have is a proxy server. Proxy server is that intermediary, like I mentioned earlier. So it's between two devices communicating with each other. So we have two types of proxy servers. We have a forward proxy, then we have a reverse proxy. Both of them are intermediary. They do the same thing. Basically, they make a request on the behalf of somebody else. That's really what they do. But a reverse proxy just do that. So it's like I want to talk to D. Okay. And right here between the conversation, there is C. Let me change a color. So we have C here. So as A trying to communicate with the D, A has to go to C. Like, hey, C, I want to talk to D. And the C, it's going to say, hey, A, I want you to wait here. Let me go ahead and ask D what you are asking me, and then I'll bring it back to you. And A is like, sure, I'll wait here patiently. Okay. So C will go to D and then ask D, hey, D, Mr. A want to talk to you about so. D is going to respond to C. Then once C gets the message, you're going to forward that back to A. So here, C is the intermediary. C is the proxy server. Both of forward proxy and reverse proxy, they do that, but forward proxy does more. Like, okay, like what? Well, forward proxy can catch the content. Let me turn this back to red. It can cache the content. In another word, imagine if we have like 1,000 computers here, 1,000 A reaching out to C. Like, hey, we want to communicate with Google in this case. Well, what C might do, it might grab google.com or grab D and then add D here. Okay? And as these thousands of computers reaching out to C, it might just get D without bothering D again. It can just grab what it has in the cache and just serve that to these machines as they're kind of reaching out. So it can catch the content, and you can see when it does that, it's going to reduce the load time and the bandwidth because it's not keep going back to D asking, hey D, what can we do here? Hey D, what I need answers. No, it does have the answers. It just responds to these requests automatically. Another thing the forward proxies can do is content filtering. Now, because it does the request on the behalf of the machines, these devices here, it can filter the content. So imagine if A is asking D something that is not appropriate. So C, it's going to come in and be like, yeah. Hold on, Mr. A, that's not appropriate. So I am now going to ask D that. In fact, I'm just going to go ahead and block you, or I will go ahead and just drop the traffic. So there's the access control that can be done if we deployed a forward proxy. There's also the anonymity. As a C is reaching out to D, it's not reaching out to D as A, it's reaching out to D as a C. So if I don't want people to know that I am A, I am the one that's asking, this is another way of doing it by using a proxy. So there's that privacy protection going as well. And because of the caching, it's going to reduce latency as this is taking place. So most organizations, they deployed the forward proxy. Reverse proxy does the same thing as far as making a request on the behalf of somebody else, but forward proxy have some security and some other features that companies like. Therefore, in practicality, in the real world, forward proxy is the one that is deployed in many environments. In the world of enterprise storage, two technology stands out, and that is NAS, or Network Attached Storage, and a SAN, or Storage Area Network. One is a file level storage, another one is a block level storage. So let's talk about this a little bit more. For a SAN, starting with a SAN, and the network attached storage, it's a storage, something like this, that is attached to the local area network. And it allows people to be able to share files, be able to kind of share storage. Let me just put it that way. We attach this to the network and we're able to share that storage with the people on the SAN LAN. Now, for that to happen, it uses a protocol, and that protocol is known as SMB, which stands for Server Message Block. This was developed by Windows. I say Windows, but it's used on Windows, but it was developed by Microsoft, and it does have a lot of different versions of it. There was version 1, version 2, version 3, and version 1 have a lot of issues. In 2017, there was these attacks, two of them. One, it's NotPetya or Petya, and another one was known as a WannaCry. These two attacks cost companies globally over $10 billion. $10 billion in damages. Back in 2017, because of this protocol, this right here, SMB. See, SMB allows you to be able to share printers, share file access, right? Share the storage and that kind of things. And guess what? When attackers get you into your environment, they can do the same exactly thing. But SMB, it's used on Windows. Now, like, oh, should we just turn off SMB? Absolutely not. If you turned it off, you won't be able to use things like printers. You won't be able to send your printing to the printer because the printer uses this exactly same protocol. So what you need to use is version 3 of SMB, V3. And the reason is because the V3 does provide security, does provide encryption and all that good stuff. But what about on Linux? What can we use? Well, we can use NFS, which stands for Network File System. It does exactly what SMB does on Windows, allow us to be able to have this centralized management file system, something like what you see here, and be able to share that storage on our local area network. It's very simple when it comes to deploying it, and it can easily be accessed via, IP, or depends on how we set it up. Some of these do have like dedicated software inside of them that help us to deploy this, but also access this very easily. If you are an enterprise organization, then you might want to go with the storage area network instead of a NAS. And the reason is because this thing is extremely fast, because we can connect it to it using fiber channels, but also iSCSI. It's using IP addresses. We can also use that as well. But it's very fast. It's high speed. It allows us to create that block level storage where we're connecting these hardware to our local environment as if these hardware are locally present. That's the beauty of a SAN, or storage area network. Now, these hardware can be anywhere, really. They can be connected to in another building, in another facility. So this is sort of like that next level storage, if you will, if we are looking for that as a business. Extremely fast, connected via fiber channels, and so on and so forth. So NAS, it's for file sharing, as a SAN for enterprise storage backends. Absolutely. So NAS does connect via LAN. SAN, on the other hand, it uses a dedicated storage networks. Often, this is the fiber channel. Wireless network appliances. Now, in today's networks, a lot of companies, they don't have a wired anymore, meaning the computers that their employees are using, they're not wired into the network. It's mostly wireless because these computers are laptop for the most part. I remember a company that I used to work for, we were all on laptops. So we start questioning because we had cables that came through our cubicles. And we start questioning, okay, do we need these cables? Because we have access points. We'll talk about this. We had access points in the different types of different locations of our buildings. In fact, we have these Unify, which we were managing them. But we had these access points, which are like hardware that give us Wi-Fi capabilities, that give us those radio frequencies. But back to the point, a lot of companies now, they prefer wireless, where they're not being bothered with the wired, right? Because they're using wireless devices now, phones, tablets, and laptops. So for you to be able to connect via wireless, you need what we normally call an access point. Access point is a hardware that is specifically designed to broadcast radio frequencies. Radio frequencies, these are like Wi-Fi signals. We have two types of those. We have these known as autonomous APs, or autonomous access points. These are the ones we use at home. Okay. And then we also have what we know called the lightweight APs, or LWAP. These are centrally managed. These are sometimes known as repeaters. You'll find these at the airports, where maybe they have a wireless controller, which we're going to talk about the next here. Maybe they have a wireless controller that is managing these lightweight access point as well. But in your house, you have an access point. Maybe you got that from one of the ISP, Comcast, or maybe AT&T if you're in the US. And that device that they gave you, it's acting as an access point. It's basically broadcasting the signals. It's broadcasting the wireless signals. We call those the radio frequencies. So once you have an access point, you are going to configure what we normally call SSID. SSID is a service set identifier. I will be coming back to this once we talk about access point in more depth. But right now, we're still talking about the appliances, the hardware that we use when we're setting up these networks. So SSID is the name of your Wi-Fi, okay? So this service set identifier is the name of your Wi-Fi. Everybody has SSID because this is the only way you are able, I probably should say the only way, but this is one of the ways that you can connect it to your Wi-Fi. It's through SSID, the Wi-Fi name. What about when it comes to security? Well, you can secure your access point, your Wi-Fi, using what we normally call the WPA version 2 and version 3. WPA stands for Wi-Fi Protected Access. Wi-Fi Protected Access. And this is what provides the security of your Wi-Fi. There's a lot of other things that we can put behind the scene, but in a nutshell, this is what we use when we are securing the Wi-Fi. We also have a standard for the Wi-Fi. It's known as 802.11, A, B, G, and that kind of stuff, which I will come back to it. But part of the standards, we also have, Wi-Fi 5, Wi-Fi 6, Wi-Fi 6E. We have Wi-Fi 7, Wi-Fi 8, right? Again, innovation, it does not stop. So another hardware when it comes to the wireless that you might be less familiar with, it's known as a wireless controller. And literally the keyword here is controller. This is a centralized hardware that basically manages these lightweight access points. You will see wireless controller in businesses, but also in airport. I should probably say airport first. Airport. The reason is, you see, when you go to the airport, you can connect it to the Wi-Fi at the airport, and then you can walk it for about like 2 miles, and you still connected it to that same Wi-Fi name, to that same SSID. Well, why is that? Well, it's because of a Wi-Fi controller. See, the airport have a bunch of repeaters. Repeaters known as lightweight access points. And these things are configured to just broadcast the signal. So you have this centralized management location, which is known as Wi-Fi controller, that's going to manage those multiple access points. So bigger organizations and airports, like I said, they set their Wi-Fi that way. And the beauty of the controller, it's going to not only manage the channel, the signals, the power adjustments, meaning how high can the Wi-Fi, what's the broadcast going to be? Can we broadcast the signal all the way to the parking lot, or can we reduce the power level? Can we adjust the power level so that the signal is not as strong in the parking lot? That kind of stuff. So we can do that in a controller. The controller has its own operating system to help us kind of manage the Wi-Fi the right way. The vendor that's really kicking everybody else is known as a Unify. And what you're looking at here, it's an example of a Unify. This is their Dream, I think they call it Dream something appliance, where you can buy this and set it up at home, but you can also buy these access points, these right here. If you're a bigger business, you can maybe buy this right here, where you're able to broadcast the signal to the long range. Anyway, they do have this Unify product where they're basically unifying a lot of this. You can literally configure this as a wireless controller, and then have these access points be those lightweights where you're broadcasting the signal pretty much everywhere. And that takes me to the networking applications. What are some of the applications that comes in mind when you think about networking? Well, CDNs. CDNs are the content delivery network. See, when you are delivering something to customers as a business, well, you might want that thing to be there quickly, right? You want to be able to distribute that as quickly as you can. Well, how do you do that? Through CDNs. This is what Netflix did. I remember I was reading this thing that said back in 2011, 2012, 2012, when Netflix was transitioning into streaming, when they were like allowing people just to stream movies online and not buying DVDs and things. Well, at nighttime, in 2012, at nighttime, 60% of all the traffic in the US was all Netflix traffic, literally. 60% of all the traffic in the US used to be Netflix traffic. So that means that Netflix had to use a lot of CDNs. See, if I am in Georgia, right, GA, and I want to access a movie from Netflix servers, I want to access a movie from Georgia, Netflix have to deliver that movie to me as quickly as it can. Right? I don't want to wait for the loading. I don't want the jitter. I don't want none of that. I just want the movie to start streaming. Guess what Netflix does? It uses a content delivery network. I think they went to AWS, the Amazon Web Services, and then it said, we need to use some of your data centers so we can get these movies close to the people who are going to be watching these movies. And that's exactly what CDNs does, content delivery network. Okay, we're going in and we're distributing the web traffic to geographically displaced servers so that we can serve the nearby people from the nearby server. Okay. And that makes this traffic very, very quickly. It's going to reduce latency. It's going to improve availability. And it's going to offload the origin servers where the content is originated from. It's going to offload the traffic from those servers as well. So that's CDNs. There are a couple of them. AWS do have one. Let me go ahead and show it that to you quickly here. AWS CDN content delivery network. They call this CloudFront. CloudFront, which basically means if you're if you're Netflix, you go to Amazon Web Services, you said, hey, I need CloudFront. And basically they're gonna will allow you to start using this and be able to distribute content through all their data centers. And AWS, let me show you this. AWS data center worldwide. Okay, let me see. Hopefully I'll see an image. There we go. Yeah, a pretty good image. So you can see that they have data centers around the world. Let's say that you're serving customers in North America, right here. Well, if you're Netflix, you want to put your movies in this data center. You want to put the CDNs or configure the CDN to add some of those Spanish movies here so that when people are streaming those movies, they get delivered to them quickly, right? Those movies get delivered to them quickly as well. Okay. All right. Another one we have here as far as network applications is a virtual private network. I will come back to this, and in Security Plus, we talk about this in more depth, but this is the VPN, virtual private network. So what happens if you want to work remote? Maybe you're stuck at the airport and then you want to be able to remote into your company's environment, be able to keep working when you are at the airport. Well, what can you do? You can use a VPN. What is a VPN? A VPN, it's a way for us to securely connect to our company's environment via unsecure network. In other words, via the internet. The internet is not secure. On the internet, everybody's doing God knows what. So if we want to our traffic not to be seen by anybody, meaning not to be accessed because they can see we're communicating, they just won't know what we're communicating about, we might want to use a VPN. Okay, and we can set up this private tunnel, right, where our traffic is going through the internet, but it's private, right, through that tunnel, going from our computer to our company's network via VPN. Okay, so we can set up a site-to-site VPN, or we can also set up a client-to-site VPN, also known as a remote access VPN. And if you're stuck at the airport, this is what you will have right here, client-to-site VPN. And Microsoft made it a lot easier. If I go ahead and type in a VPN, I don't know why I type in PNG, but VPN, there we go. And bring up this VPN settings. Let me go ahead and clear the screen here. There we go. Right here, I can literally just add a VPN. And all I need, if I'm using the built-in VPN Windows tool, I just needed to give the connection name, the IP address of who I'm connected to, meaning our site VPN, and just say, okay, this is going to be automatic. or what kind of a security am I going to use? Okay, it could be I key. Once we dig a little bit deeper into VPN, we'll come back to all this. It could also be L2TP. It could be also point-to-point. But for the most part, we are going, as far as security goes, we're going to use IPsec or IP security for the VPN, or use a TLS, the transport layer security for our VPN as well. But again, you just set it up like that. You put in the way you're going to authenticate, the username, the password. You click on save, then you connect it to it, and then job done. Now your connection is going to be secure. Your connection is going to be secure, even though you're using unsecure Wi-Fi. In the case of a airport Wi-Fi, your conversation is going to be secure if you set up this client-to-site VPN. Now, if you would just want to set up like building A to building B VPN, we can do that as well. Some companies do the site-to-site VPN from like a branch office to headquarters. Like they can establish that that way as well. Another network appliance is QoS, quality of service. When you see QoS, I want you to start thinking about prioritize, okay? Prioritizing things. So this is where we're going into, we're prioritizing traffic. Now, most of the time we do this for performance purposes, and this really depends on the kind of traffic that we're dealing with. For example, imagine in your company, your people are using email, they're using Gmail, and they're also using VoIP, voice over IP, VoIP. Maybe some people are calling each other using the internet. Okay, that's what they're using. But let me ask you this. Which one of these two traffic do you think deserve more bandwidth? Which one do you think we need to prioritize on our QoS? And the answer is VoIP. When people are calling each other on the internet, they cannot afford any delay. See, your email can delay a few milliseconds or a few seconds, and that's okay. Because there's really people don't just be standing in front of their email, staring at it and just waiting for that email to pop in. No, the email will get there once you get there. But when it comes to VoIP, if you and I are on the phone call using the internet, I called you using something like WhatsApp or something like the Zoom, right? Zoom, I called you via Zoom. All these are VoIP applications. Well, you need to hear me right there then. You don't have time to wait for my voice to take its sweet time to get to you. So for that reason, we are going in, we are prioritizing, right? In the routers, in the switches, sometimes in the firewalls, we're going in and we're prioritizing the traffic, or we're saying, hey, VoIP traffic is going to get more bandwidth. And that takes me to TTL, or time to leave. Time to leave is assigned to every packet. This is a routing function, time to leave. It usually happens a lot in a router, although things like DNS, domain name system, or domain name services also do have some TTL capabilities, but for the most part, time to leave, it's a routing function. Anyway, what is it? Well, it's designed to limit the lifespan of a packet. In another word, every packet gets assigned a time to leave, meaning some milliseconds. And if that reaches to 0, that packet gets killed. If it doesn't know where it's supposed to go, and then its TTL reaches to 0, the packet gets killed. The reason is to try to avoid looping. All right. See, when you compare this to a switch doesn't have a time to leave. The packets in the switch, the frames in the switch, they don't have time to leave. So we have other ways we do that on the switch. For example, we use loop prevention with the protocol that's known as spanning tree protocol, STP. There we go. Spanning tree protocol on the switch help us with looping. Okay? Basically, it's a way of preventing a packet or a frame from keep looping around when it doesn't know where it's supposed to go. So keep going around, and that creates a problem. It's going to slow down the network. It's going to create congestion. So what they did in routers, they say, you know what? We're not going to have those looping problems. Let's go ahead and assign a time to leave on every packet. So if that time to leave reaches a 0, we're going to kill the packets, and then we're going to send a notification that says, hey, we killed the packets. If you want, send another one. All right. Is that time again of you practicing the things that you're learning. I urge you not to skip these labs activity, perform them with me so you can kind of not only understand the material a little bit better, but also get some of that practicality, that hands-on labs. So in this lab activity, we're going to create a Soho network. Soho is a small office, home office. So we will create a network that can be used for a home office, for example, or maybe for small businesses. And this is just going to be a setup. We will use Packet Tracer to do this, and we won't be configuring anything. It's going to be just dragging a few things there and connecting them or renaming them, label them, and making sure it all looks nice. And in later labs, we will go in and configure those things as well. So here's what we will need. We will need 2 routers. So we'll set up 2 routers and set up 2 switches and drop in maybe 6 computers, 6 PCs, including laptops, maybe, like 3 for one section and a 3 for another section as well. I might put in a firewall just for the sake of it, and this is I might not. I might add a firewall in a later sections, but I might just drop that in there as well. And then maybe put in the servers. We haven't talked about servers and what they do, but servers. Maybe a web server or a DNS server. Then what we will do, since we want to organize everything, we are going to label everything and rename everything and making sure it's all clean and all looking good. So without further ado, let's get right into it. Go ahead and bring your Packet Tracer. So let me exit out of this and then search in the Windows search box there. Or type in Packet to bring a Packet Tracer. And this is a Packet Tracer. I will click on that or select it or double click on it. You can also click on open right there. Okay. Then let's give it a minute for Packet Tracer to come up. And it's loading, as you can see in the background here. And here we are. There's a pop-up that's asking me to allow Packet Tracer to work. I'm going to go ahead and click on allow. And they exit out of the Packet Tracer. I'm going to bring it back up. It looks like I opened a few of these. So I will go ahead and close some of these. There we go. And now Packet Tracer is asking me to log in. So let's go ahead and turn on and keep me logged in for the next 3 months. And then I click on skills for all. We're trying to log in as skills for all. If you don't log in, they won't let you use Packet Tracer. Let's go ahead and log in again. It's going to ask me to sign in. I'm going to type in my email address here. Now, as soon as we finish logging in, there will give you this little message here that says that you have successfully logged in. So just go ahead and back to the Packet Tracer and it should be good to go. I'm going to bring back Packet Tracer and I don't see the login pop up, and that's because I'm logged in. I'm pretty good to go. After logging in, now we are ready to start dragging things. But first, we will keep this organized. So let's go ahead and create like a little title here. When I click on this place note that looks like a notebook right there, I'm going to click on that, allow me to write stuff here. And I'm going to call this Soho, small office, home office network. All right, just keep it like that. I'll click back on this that icon right there so I can be able to move this around a little bit. Just leave that at the top right there. And now let's start by dragging in some switches. So we'll create 2 LAN, a 2 local area network. So click on the switch at the bottom here. And right here, let's use the PT switch. We can specify which one, for example, the Cisco 2960. But let's just go ahead and use the PT switch. Do not use the empty one, just use the one that says PT switch. I'm going to click on that. I'm going to drop it out here. Then if I hover over this, you can see that we do have a few kind of interface. You can see we have a faster Ethernet 1, 2, 3, all the way to 5. These are the amount of connections that are on this one. Let's rename this switch to SW1. So I'm going to double click on the switch there, and then just name this SW01 for switch 1. I'm going to press enter to keep the name like that. Let me go ahead and grab another switch, another PT switch, and put that here somewhere on the right-hand side. And let's rename that to SW02, switch number 2. Okay, I'm gonna drag them down here a little bit so I can give me a little bit more space to work with. Okay. Now, after you have a switch, let's add some computers. Click on the end devices. And right here, you should be able to see a few machines. You should be able to see PC1, laptop, and then server. So here, we will add 2 PCs. So click on the PC, then drop a PC here, right there. Pick another PC and drop another PC here, right there, just like that. And then let's click on the laptop, and then let's drop a laptop right there. Okay. And then on the server, let's just grab a server. Let's click it right there. Let's put a server on the side like that. And for the server, let's rename the server to web-srv for the server. SRV. There we go. I'll take it. Well, let's just keep it web. All right. Let's just keep it web to keep it a little bit clean here. Everything else, let's just leave it on the default. The names are looking good. Okay, we haven't connected anything, but this is what we need. Let's do the same thing for PC2 right here. So I'll go ahead and grab a few PCs. I'll put a PC1 here. PC. Now the name continues. So that's PC0, PC1, PC2, PC3. As you can see there, I'm going to keep the same name. Then let's put the little laptop here. And let's add a server to the mix right there. Let's rename the server to DNS, domain name system server. Okay. And we have the switch right here. Finally, let's add some routers into the mix. So I'm going to click back on the network devices right here. And I should be able to see routers pre-selected. Now let's pick the PT router, the second from the last. And I'll add that here somewhere. Just put that there. And let's just rename this to R01. Just call this router 1. And let's pick another PT router. And let's just add that here. And let's just call this R02. R02. Okay, or router 2. Now, after we have all the devices we need, we won't be adding a firewall. After we have all the devices we need, it's time to connect all of them. So I haven't taught you about connection yet, but click on the connection icon that looks like a thunder icon or the flash. There we go. And like I said, I haven't taught you about console cable or copper straight through cables or crossover cables or fibers and so on and so forth. So we are going to use the automatic. We will let Packet Tracer pick whatever cable that is going to use. For example, since we're connecting devices that are similar, it's going to use this crossover cable for that kind of stuff as well. Again, I will teach you all about cables once we get there. So I'm going to go ahead and connect the router first. I'm going to click on router 1 and then I click on router 2. Here we go. Now they're connected. It's all red because we haven't configured anything, so they're not communicating with each other. They don't have IP address, none of that, but they are connected. And let's connect these routers to the switch. So I'm gonna click back to the automatic cable. I'm gonna click on the router again, then I'll click on the switch. Okay. And I will click back to the automatic icon, click on the router 2, and then I click on switch number 2. There we go. We're pretty good. And now it's all connected, but nobody's talking to anybody. Let's connect the rest, the computers now. So I'll click on the automatic and then click on the switch. Then I connected the laptop first, automatic, click on the switch, connect to the PC1. Automatic, connect the switch, click on the PC2. Automatic, click on the switch, click on the server 1. And oh, this is actually a pretty good one. I get a connection error talking about the cable cannot be connected to that port. And I believe the reason is because the switch is running out of the port that we can connect it to the switch to, because I picked the very basic switch in this case. So I think that we can only connect it to 4 things. 1, 2, 3, 4. Yeah, we maximize 4. So I'm going to click OK right here. Then I click back on this icon right there to get rid of that wire. And let me click on the switch to verify that. So click on the switch. And yeah, sure enough, here's the physical device view. I can zoom in here quickly for you. And we can see that we have these LAN 1, 2, 3, 4, and these are the ones that we're connected to, which you have 1, 2, 3, 4. Okay, so let me go ahead and change the lab for a little bit so that we can, accommodate the server instead of, 2 PCs. So what I will do, I'm going to remove PC1 and add PC1 on here, and then just remove these 2. So instead of having a PC, 2 PCs, we're just going to have a laptop, a PC, and then a server. Okay, let me start by getting rid of a PC1. So I'm going to click on the X icon, the delete icon right there. Then I'll click on a PC1 to delete PC1 and click back to that icon, the other one. Now we have PC1 is gone. Let's go and connect the cable to server web. I'm going to click on the flash cable again, and then pick server. Now we should be pretty good right there. And now let's get rid of a PC3 here. I'm gonna click on that. Oops. Let me make sure PC3 is selected. And get rid of PC3. It's gonna ask me, you want to do that? Yes, I do. Okay. And let me go ahead and connect these to the cable. So I'm gonna start with the laptop. I'm gonna click on that and click on the laptop. And click on that and I click on the PC2. Pick the icon again, click on that, and click on the server. And now we have these things connected to each other. Pretty good. Now let's go ahead and rename one of these PCs here. So let's see, this is a PC0 and this is a PC2. Let's change this to PC1. I'm gonna click on the 2 right there, and then will allow you to edit this. So change that to 1, press enter to keep that. Now we have PC0, then PC1. Very good. So this is local area network 1, this is local area network 2. Let's actually put that here somewhere. So I'm going to click back on this place note icon. I'm going to click in the white space here. I'm going to call this LAN 01. Okay. And let's just call LAN 02. Then click back on that and just drag that here, right there. Right, LAN 2, LAN 1. There we go. So we have a local area network 1, a local area network 2. Then maybe we can call this a WAN. Absolutely. Why not? Let's call this a WAN. WAN. I just call the whole thing wide area network. There we go, because this is a router communicating with another router. Okay, and they do that via a wide area network. So this is looking pretty good. And if I want to see the interface, which is something that we will build on top of, I can click on the options and go to references. And once I'm here, I just need to select here, show port interfaces right there. Always show port labels. There we go. Let me click that so you can get to see it. So once we start configuring this, we will need to know exactly which interface our cable is connected to. And that's where we will need to go so that we can specifically say, okay, this IP address belongs to interface FA01, that kind of stuff. It's going to be fun. But you are pretty much done. This is it for this lab. We just want to set up like a Soho network. You've set up a few devices, including a router, a switch, a laptop, a regular desktop computer, and a web server. Now, again, we will be configuring networks and IP addresses once we get there. As you can see in Packet Tracer, they're going to show you the things that are talking to each other via these colors. So we can see that these computers right here on the local area network, they're communicating with each other. Because, like, look, when it comes to a LAN, you don't need IP address, right? You can just communicate via what? Via MAC addresses, your media access control. So these are all configured with the MAC, and they're like, you can literally send something from a server to a PC1 and vice versa, and it's going to work because it doesn't need to go outside of the network. Now, later on, once we're trying to get these computers to talk to each other, because they're on this different networks, we will need the help of a router. And that's where we will assign IP addresses to all these interfaces so that we can be able to communicate from one local area network to another local area network with the help of a WAN, or a wide area network. Now, once you've done set this up, let's go ahead and save it, because we will need this. We'll need to come back to this over and over again. So we'll click on the file, then save as, then navigate where you have your lab environment. So for me, I'll go back to this PC, go to my C drive, go to sec lab, then net plus labs, and here it's where I want to save this. So let's go and call this, let's give it a name, Soho, small office, home office, keep it capital, small office, home office network. Yeah, they just leave it as that. And this is going to be saved as a PKT. This is the packet tracer file. So just type in the name in the location where you want to save that, then click on save. Okay. And after waiting for a little bit, now that have been saved. So next time when we want to, we can close this. Okay. And they're gonna say, oh, any unsaved changes, you just click on yes. That's closed. Next time we want it, we can just go to where we saved this from. So I'll go back to this PC, go to the C drive, go to the sec lab, net plus labs. Now we have the Soho network right there. So all you do, just double click on that, then it will open in Packet Tracer. And from there, we can start configuring it and do all kind of things that we want us to do. And this is the network that we just created.